team is
thanks for adding me.
yeah. There was like what's it called? It's the same number, but like when I added you through as a contact to them, your message in the morning, I figured, oh, now it's working. Yeah, sorry for that. Exactly.
So we'll begin in 10 minutes, okay? It's nice we're here again. We're beginning the second day of our conference. We begin with the second keynote speech that is prepared by Professor Anetta Kępczyńska-Walczak from the Łódź University of Technology, and it is titled Revisiting CAAD 7 Deadly Sins. Any prospects for redemption? Anetta, scene is yours.
Good morning, everyone. Can you hear me? Yes, that's good. That's a good start. I'm Anetta Kępczyńska-Walczak. I'm head of Department of Digital Technologies in Architecture and Urban Planning at Łódź University of Technology. It is in Poland. Well, my background is architecture. I completed master in architecture in Poland. Then I completed postgraduate diploma course in computer-aided building design at the University of Crete in Glasgow. And after that, I started teaching and developing my research. So it led me to, again, to the University of Crete, that I was really honored to be supervised by Professor Tom Maver towards my PhD that was completed and awarded at the University of Crete. My further path was back in Poland, and I developed research and struggled with realities that are in Poland and in this region of Europe, and that sometimes we do want more that we can, than we can and we can afford. But still, I'm here in this half-digital world, teaching students, doing research, and hoping for a better future, as always. Some of you might have met me in Łódź, maybe, at the CAAD 2018 conference that I was honored to organize, or maybe to read proceedings entitled Computing for a Better Tomorrow. I'm sure you've got it here in the library and in the libraries at European universities that if not you, your supervisors might have been there. Maybe some of you can spot them on these pictures. At least three, well, from my yesterday estimation, at least three supervisors of yours are here today. Before I move to the topic of my lecture, first of all, I would like to thank the conference host for the invitation and also for kind of a it's really brave move for launching a new series of scientific events under a very appealing name, DARE. So I wish you all to enjoy it. Yes, yesterday was marvelous, and I guess today it will be indulging. So, as the conference call has been addressed to young researchers and PhD students mainly, I assume the audience may not be aware about the uniqueness of this place. However, thanks to the first keynote lecture yesterday by Wolfgang Dokonal, you heard some bits yesterday. So it has passed 30 years already since the conference on computer in didactics and architectural design was held in Bialystok, and then two following conferences in 1994 and 1995. It is a meaningful place, not only from the local perspective, but also a wider European dimension at least, because in the 90s it was the time when the research area of architectural computing started to accelerate. Some of you may have heard or even had a chance to participate in CAAD Regional International Symposium. In 2014, such symposium was held in Bialystok and focused on a hybrid environment for architecture and the new architectural design space. And again, I had the privilege to be here and to participate and really enjoy it. So it was a fantastic, inspiring event. So as soon as DARE was announced for the first time, then the difficult time, pandemic time, the immediate comments on social media appeared. Guys, Bialystok is back in the game. So now here we are, and I'm really happy that you are in the game again, and you will be warming up Poland towards this direction. To quote the organizers, their conference offers a perfect opportunity to exchange knowledge and to discuss concepts and developments in the field of architectural computing and design digital media. I would also add a discussion on research methodologies and processes, as it may be not so simple and obvious. We heard some presentations yesterday, and we could see how advanced were your topics of research. Some of you maybe are at the start of your dissertations, some are completing. So this topic is also not the same through the whole PhD studies and through the research process. Therefore, I would like to start with a question to the audience. How would you describe the research process you are experiencing during your journey towards doctoral degree? Yes, any thoughts in the morning, wake up thoughts? Yes, we have the first.
Constantly changing. The idea keeps on evolving, and it's like a never-ending story. Maybe I should say it again?
Yes.
Okay. Sorry. The idea is constantly evolving, new perspectives of changing the research topic, and basically always doubting myself if this is enough or I should be doing more and more and more. It's kind of like the spiral of like the Mobius curve. Thank you.
Thank you. Any other?
And to fulfill, after the doubt, you suddenly discovered that there is always someone who haven't had this doubt, and then you proceed with the research.
The idea of learning from each other, constantly researching and being, learning from each other, being, that's all.
Okay, thank you.
Yes.
That you're not alone after all.
That's true. Right, so kind of maybe some more hints to develop this. So my question would be: is this process structured or unstructured? Okay.
Difficult question.
Is it linear or hierarchical? Yes, we are talking about processes. Okay, so someone is waving already. So no line, no hierarchy. Yes, it's waving. Thank you. So is it starting from a specific issue towards more holistic perspective, or on the opposite, from general to specific? Yes, can you recall how you started? Those who are quite advanced, I'm pretty sure that your path, your journey was not very simple. Cannot be. Okay, so maybe is it browsing, searching, and grabbing bits of, as you already said. Or is it an in-depth study of all aspects found on the way? Yes.
Any comment?
Diagonally.
Yep.
I think as we conduct our research, we find more in-depth information, and we have a tendency to reevaluate our idea and try to possibly shift it into a new aspect. So finding out and then adapting it to our research, or adapting our research to the new knowledge.
Yes, yes. And sometimes we are in a trap because we are going too much in depth and we realize that we are somewhere else where comparing to where we want it to be, right? Or sometimes maybe it is rhizomatic. Yes? Do you know this concept, rhizomatic? Okay, so you are not familiar with the concept. So I planned to skip the slides, but now I'm not. So rhizomatic is a philosophical concept, actually, and it was developed by two guys. One was a psychologist, and the other was not. So Gilles Deleuze and Félix Guattari, and they argue that traditional thought is tree-like. Yes, any thought you can think about, then it is like a tree-like. In that, it follows a linear pattern branching off at various points. But still, there are kind of lines. Yes, they are distributed, but there are lines that build a tree. Rhizomes taken from a kind of a root system found in nature are not linear and non-hierarchical. So a rhizome, unlike trees or the roots, connects any point to any other point. So you may just reflect it to the way you process with some issues at your studies. And its threads are not necessarily linked to threads of the same nature. That is why some novelty may come out yes, with this rhizomatic way of thinking, studying, and processing. Rhizomes grow as networks of roots with no specific or explicit center. When split, each separate piece of a rhizome is capable of growing a new plant. So let's move to rhizomatic learning. It refers to the complex and often messy nature of learning, but it's not shame in this word messy in this regard. Rhizomatic also refers to research that allows for multiple non-hierarchical entry and exit points in data representation and interpretation. So following and building up, upon the variety of your research experience, as well as methods and processes, so I believe that this is starting to process in your minds now. Let's revisit CAAD's 7 deadly sins together. In 1995, the shortest ever paper on computer-aided architectural design was presented by Thomas Mather, professor at the University of Crete in the UK, and became famous the moment it was published. It may be to your surprise, the paper from 1995 reflected upon over 25 years history of CAAD that had passed in 1995 already. In the paper, Tom Mather took a critical view of the directions of research and development in architectural computing. The criticism was set out as 7 deadly sins named as follows: macromyopia, déjà vu, xenophilia, unsustainability, failure to validate, failure to evaluate, and failure to criticize. So 7, yes, we have 7 deadly sins here in 1995. So let's have a look what they mean and how sinful we are. So macromyopia, what is it? Any ideas? Have you met this concept? Okay, so I will explain it. It is the tendency to overestimate the short-term impact of a new product or technology and underestimate estimate its long-term implications on the marketplace and how competitors will react. In the architectural computing research context, it describes overzealous claims resulting into overestimation of the short-term impact and underestimations of the longer-term impacts. Well, 20 years ago, Professor Mather observed, in today's CAAD community, it is almost impossible to find a PhD thesis which claims anything less than all singing, all dancing, fully integrated, multidisciplinary design decision support system, which does the business as soon as you press the start button. So here is the question for you, for your reflection. How is it today? Are you aiming at this magic button? Yes, please.
In my opinion, I don't think it's just computers is also the whole process, like starting from sketching, from the actual hand, let's say, drawings, and then convert it into the digital world and coming back again. And it's like this whole process, in my opinion, is just not just the computer. It's, yeah.
Okay. Any other?
I think we have learned a little bit in the past years, but
Yes.
nevertheless, if you look at, let's say, diffusion models, Midjourney, ChatGPT, yeah, then now we are saying, in 3 years, the architect's business will not be here anymore. Yeah, or this is going to take over the world. So for the component parts, we are still doing this.
Thank you. Okay, so we move to the second scene, that is déjà vu. Well, intuitively, we all know what this scene is pointing out in the context of digital architectural research. I suppose, yes, that we can guess. What had been developed was developed again, and probably again is under development now. It's okay, but is it okay if it is not with reflecting upon past work and achievements? So here is the author's view. Yes, it is extraordinary to observe with increasing frequency the emergence of new ideas in the field which have striking similarities to early, abandoned and almost forgotten work from 2 decades ago. While it is flattering to the pioneers to have many of these relevant ideas revisited, it is said that the current effort does not build upon what went before. So, any thoughts again? Yes, and examples. Maybe you discovered such repetition of ideas and work while doing analysis or, well, state of the art in your research area. We could see yesterday a lot of state of the art, yes, and examples and how you were in depth with these studies. So, was it once, twice, or many times developed in the past, but somehow, well, did not go through?
I've been actually corrected by the president here, Professor Henry Achten, during one of my PhD workshops, that what I've been presenting was already done. It's something that has been researched, but my answer to that, and it still is that the change in tools and the change in approach may provide some more valuable feedback, and especially since I think it is the point of research is to constantly doubt existing tools and existing methods and try to reinventing through or approving or disproving through reinvention and re-involvement in the process of the given tool or the given method.
Mm-hmm. Okay, so it's maybe that the semantic, the idea is similar, but the tools are different, yes, and the capacity of the tools and what you can do, yes. So this is kind of a message, I guess.
May I have a comment also?
Yes, please.
I think nowadays, when it's quite easy to, when we have quite easy access to research databases which are very rich. There are millions of possible references, and it's quite also easy to omit those very important or basic for the given issue. Of course, this is not to say, don't worry, you're doing all right. No. The responsibility of the researcher now is to go deeper and be be always awakened with the grounding the research on the relevant references.
Mm-hmm. Okay, yes. Okay, thank you. So we will move forward to this third one. Well, xenophilia, in short, it is the obsession with importing concepts and procedures from other disciplines, so that the core discipline somewhat disappears. And the question is, if we are attempting to grab from different disciplines, or they are needed nowadays, or maybe we are forced to be interdisciplinary because it's more sexy nowadays than be like in one domain. So as you see from this quote, that this import from language through to artificial intelligence has diverted intellectual effort from the central task of identifying and understanding what lies at the heart of architectural design itself. Yes. Any comments? Mm-hmm.
Like, I mean, like architecture is always like interdisciplinary, according to my view. Like, it's not new, like we don't benefit from that. Actually, we need to at the beginning. So the force, I think it is good. I mean, like, you know, nowadays we should already included that one at the beginning. Mm-hmm. So not with the like contemporary things that pushing us to do. I think it must. According to me, I mean, maybe I'm wrong, but we are dealing with a lot of stuff, not just architectural way of it. So, yeah.
All right, so with this scene, I guess that we are healed already. The fourth one, the fourth deadly sin is unsustainability. So we all know what it means, and let's have a look at it from the perspective of the year 1995. So it was said that increasingly the R&D effort is focused on the architect, not on the building. Such work that is focused on the building is predominantly concerned with form rather than function, style rather than substance, concern with fitness for purpose, cost effectiveness, and environmental sustainability has all but disappeared from the R&D agenda. My question is, are we still there?
I think we are 180 degrees in the other direction. It's much more about cost effectiveness these days than about the architecture itself.
Yes, yes. It was quite recent that even star architects, yes, star architecture, but I think it's gone already, yes. As you said, yes, we turned.
So it turned to another sin.
Yes. So the question is, can we see a tiny chance for redemption? So taking into account, well, the environmental footprint and the awareness of it, green energy, passive housing, circular economy, new European Bauhaus, Green Deal, to name a few. Maybe you have more on the list to put, yes. So what has changed? Maybe you are too young to see changes because you are in this change, yes, for some time. Some older audience could say, okay, it has changed, yes, it had its turns, and now we cannot say that architect is the, well, the central point of the design. Yes, it's not architect anymore. So the next scene on the list is failure to validate. And again, I would immediately show, here is what was observed in 1995. Each new international conference generates a plethora of even more exotic claims, few, if any, of which are substantiated by prototype implementation, let alone validation. In any other discipline, the generation of hypotheses without some rudimentary testing would be laughed off at a conference platform. So the question is, how is it now? As you see, it was kind of strong words used, but they were based on real observations at the time. And I must say, it continued. Yes, there were a lot of promises, and me as a young researcher was kind of taking notes and looking for the results that I was overwhelmed at the conferences. And there were no results, nothing there. Yes, no testing, no validation, no future for huge projects, sometimes involving money, resources, and it was kind of a wow at the conference, and it was all. So, what is your experience in this regard? How is it now? Oh, Bartek. You are saving the group.
I want to come and sit closer.
I think even the presentations that were shown on yesterday are a proof of tendency to reinvigorate the need to validate. So whether through simulations or through design tools that are implementing solutions in the BIM and BIM-oriented design workflows and design pipelines to validate certain aspects, because this just proves to be much more cost efficient in the end. So it's better to redesign the building than rebuild it. So it's just cheaper, faster, and less stressful.
Mm-hmm. Yes, that is true. So you observe the increasing responsibility of the research that someone is conducting. Mm-hmm.
Okay. Yeah, but what I think, after having been to many conferences, it is still the case, sometimes even more so, because now people need to publish, get points and stuff like that. So there is a driven to go to conferences and publish papers, and not always they are that much worthy being published at that situation.
Yes, that is true. Okay, so let's move. Well, maybe the question, are we guilty or not? Yeah. You don't need to say it aloud. It's Poland. We are just not saying it aloud. It's a different culture. So the next one is failure to evaluate. And here is the quote. So even when prototype software development has taken place, there is little recorded evidence of investigation of its usability and functionality in teaching or practice. The absence of any credible user feedback means that further research and development is undirected and vulnerable to academic drift. The failure to evaluate brings another thought. Academia is drifting, but the industry isn't. Do you agree? Or maybe some of you are lucky that you are in between academia and industry, so you're taking the best from two.
I think, if I may, I think that there is a strong shift that we've seen during last years in the area of software developments, that industry takes the rule. In fact, especially with the tools for architectural design. And it's really interesting to see how these platforms or tools grow in potential possibilities of the software, but they do not change structurally to fit both architects' needs and the process of construction, although these industries claim that BIM is already a mature concept that that works beautiful and it's easy to achieve. Yeah.
Mm-hmm. And I think that the part of the software hit the wall with the usability. So there is, like, the software houses are afraid of evaluating usability because, let's say, you don't need anything else from AutoCAD since 10 years. So now, as you realize it, you now know that you cannot even buy AutoCAD. You need to subscribe it because it's not developed for architects anymore. I mean, we have all the functions, we have colorful lines. So then the usability feedback for software houses may be kind of frightening because we don't need any more tools in terms of some software.
Mm-hmm. Yes, on the other hand, in a BIM environment, it is going to be sessions on BIM today. Yes, what we can observe, so opposite to AutoCAD, that is a perfect example of one perspective, that software developers are developing actually their software faster than architects can consume. Mm-hmm. There are so many options, sub-options, sub-options, that you do not have time in the project timeline just to even to have a look and try. So on the other hand, when we move to research area, we are not aware that it is there. Yes, so we develop from the scratch. Mm-hmm. And then a guy from the industry is coming and saying, well, we have all there in our software. Mm-hmm. Why are you trying to mm-hmm. reinvent the wheel? Mm-hmm. So this is also kind of a dissonance between academia and industry, mm-hmm. that it is more like kind of a speed game, not collaboration in full. Mm-hmm. That is my observation, and also years of experience and on research and practice. Okay, so what is also interesting in this quote, what I actually noticed being aware of UX nowadays, so this quote came back to me with a new, fresh observation, that the user experience feedback issues are noticeable in the quote. Yes, so it means that they were in the air 20 years ago already. And however, nowadays, it is claimed that UX and UI is a new concept. So are we experiencing déjà vu in this regard? Yes, because UX, wow, I'm a UX. I was architect, by now I'm UX. It's a new branch, we are going into it. Mm-hmm. And it is there. Mm-hmm. And it was artificial intelligence there, yes, mm-hmm. a couple of slides before. So, as Bartek said, yes, maybe tools are changing, but some concepts are not. And also, Wolfgang, beautiful pictures you showed with this machine. Mm-hmm. Hmm? Yes, so the last thing on the list is failure to criticize. Oh. So let's read the quote from the original paper. Above all, we have failed to exercise our critical faculties in relation to almost all of the research and development carried out by ourselves and by our peers in recent years. There has been a cozy conspiracy in the community to condone, even encourage, self-indulgent speculation and solipsism. A truly bad example to set for young people in the academic community. Well, this time, who is guilty? And what is your experience of this conspiracy? Is it still there?
I'm not sure if there is a conspiracy, but we are very kind to each other. It's never nice to tell someone that this work absolutely sucks and has no future. Yeah, and of course you can be the harsh critic and destroy and tear down everything that you see, because you can always criticize something. Yeah, it's much harder to say, okay, there are many weak points, but consider to move in a certain direction in which you can actually improve things. Yeah, and I hope that that is what we are doing. But of course, the criticism is very important, and very often we don't do it because it's not nice to criticize.
But it's easier to criticize when you're in incognito mode. So let's say we have peer reviews, blind peer reviews, double blind peer reviews. So there is still some small but valuable space for criticism, I think, that in this peer reviews that sometimes are quite changing for the world. But you have to have luck for a good reviewer. Mm-hmm.
As we are in the middle of reviewing for EKD, I can add to that, because in fact some of the reviewers who tend out to have no time at all or something, they tend to be cozy and nice to the abstracts, because that's much more easier than to write a proper criticism about something, why it is really, or in what direction it should improve. And therefore, we still fail to criticize from time to time.
Wow, so it's a totally different, approach to it, but still it's kind of a failure, right? Yeah. Yes, that's true. And either you are very shy, or you are lucky that you haven't experienced the situation that your teacher was kind of a master and you couldn't say a word to discuss with him or her. But it was kind of a tradition in many Polish universities that you would not argue with. It was not good to argue, and it was proper to read all papers and books of this teacher, even you didn't agree. So it is again another kind of a path, another rhizome for this issue. Okay, so having revisited CAAD 7 deadly sins, I asked myself what would be the list of sins if we define them today? Because I said maybe it's too old, maybe it's outdated, something is still present, something not. So eventually, on Thursday, 16 February 2023, what I did, I asked AI, what are the 7 deadly sins? CAAD deadly sins, yes. So the answer was immediate, popping up on the computer screen faster than I could read. Here is what was produced by AI. And may I ask you to read? I would like you to participate and to read it loud, each person 1 point at a time. So maybe those who didn't discuss want to take the floor now. I enlarged the font last night, so I hope that everyone can read it. Okay? Bartek says yes, but so it means that everyone can read it, because Bartek's at the back. Yeah. Yes, so yes, please. The 7 deadly sins of computer-aided architectural design are as follows. May I ask you? Yes, you may pass the microphone. Yeah.
First one is sloth, relying too heavily on CAD tools, leading to lazy design processes that lack creativity and originality.
Pride, believing that one's CAD skills make them infallible, leading to designs that are overly complex, difficult to understand, or impractical to build.
Envy, coveting to work of others and becoming overly competitive, leading to design that prioritize style over substance and plagiarizing the work of others without proper attribution.
And the fourth one, greed, prioritizing profit over quality, leading to designs that are cheaply built and unnecessarily expensive.
And the fifth one is gluttony, becoming consumed with creating a perfect design, leading to overcomplicated designs that are difficult to build or maintain.
Wrath, becoming frustrated with the design process and lashing out at colleagues or clients, leading to strained relationships and inactive communication.
Last, becoming overly enamored with the latest CAD software or technology, leading to overlooking more practical or cost-effective solutions and relying too heavily on certain tools or software.
Yes, so it was the last one. Thank you very much for your contribution. And now, how would you comment the result? What would you say?
I have a question. You try to observe, ask same question, because sometimes when you ask same question repeatedly, you give you different answers. So if there's more sins than 7, maybe there's 70 sins.
I just, did it according to the book that I was taught that there are 7 deadly sins, no less, no more.
Yeah.
So I typed 7.
Answers on the same question.
You mean that to repeat the same? Yes.
If there's a prompt, give me 7 deadly sins of computer-aided architecture design, and this thing is listing those sins, and then you ask, can you name others, but don't put the same as previously, and it gives you another 7. It's just, I'm curious.
No, I didn't do it. Yes, I wanted this pure 7, like first on the list. Yeah. Yes, but I experimented with questions, and I decided to type the prompt specifically to be as similar to Tom's Maver title of the paper as possible. But what I did afterwards, I searched for references. And you know what AI is doing with references? It's totally mixing it up. You can see real names. There was no Tom Maver, by the way, on the references at all. The most cited paper on CAD scenes. But there were a few. So generally, it is capable to give you 5 references. Whatever you ask, 5 references, you can be sure that you've got. So maybe for a short paper is enough. But when you want to find this reference, any of these references, you may find out that, okay, this guy exists, this title exists, this journal exists, but there was nothing like that in reality published. Yes, so fake numbers of pages are real in these references, but they are not there. So in my quote, in my prompt about references, what I received was, I think, 3 titles by John Giro, and none of them in CommuniCAD or wherever. But the title that was given was by someone else. So it's a quite interesting reflection. But chat is very polite. Yes, so I asked chat, what is the benefit? You know, it was a very gloomy day. And I asked chat, what is the benefit of living in Łódź? And the answer was kind of a list of ideas and a little bit, well, novel to me. But at the end it was, remember, you can find positive aspects of living in any place. Yes, so yeah, so what we have is here. What I saw, it was, well, for me, well, there is no doubt, yes, it was kind of overwhelming, these arguments and, well, these ideas that were developed by artificial intelligence. So I no longer dare to ask ChatGPT about redemption. However, I believe we could observe along the way today that some flaws in digital architectural research have been overcome, but some are still present. And thank you very much that we all could discuss it on the go. I trust that after this somewhat rhizomatic lecture, everyone can draw on lessons and discover new perspectives in the field of architectural computing research. Let me draw a final conclusion. In 1995, CAAD's seven deadly sins may be read today not as a list of deadly flaws in architecture computing research merely, but as a universal guideline for conducting a valuable, sustainable, and useful research in architectural computing. And therefore, the list of sins may be rephrased to work as a researcher's decalogue. And thank you for your attention.
Thank you very much. We still have time for questions or comments.
Back to GPT, we did observe that it's perfectly confident about being wrong.
Yes.
And I think I have in my head the sentence from yesterday to choose right tool in the right time. So I think people might expect too much from that ChatGPT because it's based on probability. So it put another word about being what is most probability. So the if we did observe, if you want to use this tool with some benefits, it's all about prompt, to understand what is really the goal of using this and intention.
Right. Any other comment or question? Yeah. Yes. Sure.
Thank you for the presentation. Actually, I was going to ask you, like, do you plan to add more scenes on it? But you used to prefer to ask ChatGPT. Like, is there any ongoing process to find these scenes now, this like area, like contemporary one, like current, without ChatGPT, like direction for research?
Yeah, I think you mean the list of flows nowadays is outside ChatGPT. I would plan to ask you, yes, to confess, because it is you who are doing research, I mean, as PhD, because it was the context of PhD and research, and these doctoral studies that can give you pain and happiness, and pain and happiness, and satisfaction, and, well, final reward. So I believe that you've got it, and I believe that when you reflect on this lecture, even in the process of processes or different processes of starting your research and then going through it, as Bartek said, yes, he started to do like that. When I asked, yes, what is the path, linear, hierarchical, and he, is it sinusoidal? What was that? Yes. yes, with some. So I mean that on this road, on this path, you may have spot some flows, yes, and you may say, okay, maybe it is time to kind of review what I have done by now, and is it enough that I reflected on the history of CAAD, or maybe that something was done. Okay, my thing is different, yes, it's not different because it's better, but it's different because the list should appear, yes. So this argumentation must be somehow reasonable, and again, looking to the future, looking for sustainable solutions. That what I liked very much at University of Crete, it was that research must be useful. Yes, so do not invent, something that is like floating somewhere, and then it's for nothing. Yes, you are using time, resources, and you should give back to the society what best you can do. So this was really appealing to me, and what was and very strong, and it helped me to structure my PhD and the way that I followed. Right.
Very good.
Yes, I think it's interesting how you approach the topic of the seven sins of architectural design and research and all the things that incorporate it. But my question to you is, what do you think are the seven non-sins, like the 7 good things that are being done currently in terms of architectural research, architectural design, like so that we perhaps may end on a good note in terms of the near future. Thank you.
Mm-hmm. Well, I should not respond very general, because I'm not aware of everything what is undergoing. But from my observations, what is really good is that research projects are going to direction to be practical, to be implemented, to have this potential to be implemented, to be used, and to be useful for in future. And this was the case also of my PhD student. Actually, I was not really believing at the end that someone would be using his solution. And it was just last September at the conference, the CAAD. It was this workshop. Some of you participated in the past, the doctoral workshop. And out of sudden, a student from partially from Spain, partially from Italy, and partially from Australia, because of the combination of supervisors. So he presented a paper, and out of sudden I said, "Wow, I know it. And since my PhD students were defense, some time passed, so it doesn't mean that I didn't remember, but it was like, oh, yes. And then there were references, and I saw these references, and he said that he wanted to develop that, but he found it, so he built upon it. Yes. So, and he said it was very good that it is for people, for others to share, and what he is doing, he's going also to share the outputs, the outcomes of his own studies. So, I mean, if we refer, yes, if we build upon someone else's job that was good job, that's, I think, the future, yes.
There's actually a reference for that. Alexander Koutamanis in 2016 wrote a paper in reaction to Tom Maver's CAAD's 7 Deadly Sins with the title CAAD's 7 Arguable Virtues.
Yes.
I don't remember the virtues anymore. I'm probably a sinful person, but you can find it in the IJEC journal of that year.
Yes, and Communicat. Yes, Czech Communicat. It is in Communicat. Yes, I also read it too, but I decided that it will be focus on the original. Yes.
Do you think that there is a way how to know in advance that your research will be useful and that people will use it in practice, or where lies the line in between the research and, let's say, a startup company or R&D within certain company? Because sometimes if we are researching something new, we don't really know what it will lead us, and if the end will be useful. Maybe we will just find out that it's not useful and that other people don't need to follow this direction because we already verified that it's not useful.
Yes, it is this risk that researcher takes. Yes, that especially then the doctoral studies, it's not like 6 months, it takes time. So it is also, well, depending on the topic, but if it is a topic like digital technologies, it is a risk that someone else will be faster and you are not aware that somewhere in the world the same stuff is under development, and also in the industry. So it is again another risk that you as researcher are pure and honest, working in kind of in a bubble, and then in the industry it's almost done, commercialized, and what is this new novelty in your research at the end? So it is really, yes, kind of a very risky stuff in this regard. Yeah. So I would say you can make assumptions, yes, what would be useful, what would be for good, for future. It's like the conference was Computing for a Better Tomorrow, so it's just bringing better stuff into the world. But yes, but it is risky.
I have a question. Is commercialization and awareness of commercialization of some solution an argument not to conduct research theoretically that may be open sourced, for example? Should you stop the research if something was commercialized, so it's behind the paywall?
Well, that's actually a question on the rules of each university or institution, because in some places we cannot commercialize and sell, yes, the produce, the research produce. In some, people are encouraged to cooperate with companies, as for example in Sweden, in Halmstad, at the University of Halmstad, they have companies in the same building as they have students and the same canteen. And they say it's helped with these ideas exchange, business exchange, and to also to organize better practice for students, yes, so apprenticeships. So it was really a different approach, but it works. So I think there's no one answer, at least from my point of view. What is your perspective? How is it at your universities? It would be good to hear.
I think I can add to that. In Austria, for example, you know, universities are kind of semi-privatized. So we still get the main money from the state, yeah, but we're allowed to earn money with projects like that. And that ends up having the big discussion of how much, and I'm missing the English word now, but maybe someone can help me, so-called Grundlagenforschung, which means research on the basics without a very special research topic towards an end that you can commercialize, but just doing research and looking what might come out in a certain field. That's not too popular anymore, because the rector cannot put a price tag on that kind of research, and it might cost a lot, and it might lead to just those results that you know this isn't working. Yeah, But that's, I think, probably a discussion everywhere at universities, how much of this Grundlagenforschung, which means the basics, research on the basics of a field, is done.
Mm-hmm.
Yep.
Okay, thank you.
Thank you very much, Anetta. Thank you all. Now we have a coffee break and we are back in half an hour, okay? Thank you.
Good morning, everyone. Once again, we are ready to start session number 3, which is BIM and Digital Prototypes 1. And I'd like to welcome to the stage Mr. Panayiotou. So big round of applause for our first presenter for this panel. Yes. Use this one.
All right. Thanks, everyone. All right. Perfect. So, my name is Panayiotou. I'm a PhD student at the University of Cyprus, Department of Architecture. My supervisor is Kontovourkis. And we did this, and this research is made under his supervision. Also, just to mention, Kontovourkis is going to organize their CAAD 2024, which is next year, just to mention that. This research is based on a Scan-to-BIM methodology for the digital reconstruction of timber structures. The aim and objectives, the development of a unified computational design framework that incorporates different types of timber roof structures, the ability for a much more detailed geometrical 3D model compared to previous research works where the geometry was created by extrusion leading to simplified geometries. And third, the development for a data-rich building information modeling BIM attribute catalog for the reuse and maintenance of timber structures. The methodology starts with the typological organization of timber roof systems according to their geometrical characteristics. Then is the Scan-to-BIM workflow for the automatic creation of 3D geometry from point cloud data. And then is the specification of BIM attributes from existing timber structures. The typologies are related to heritage buildings, but also buildings to be reconstructed and demolished with a timber roof construction. The aim of the typological organization is to assist the Scan-to-BIM methodology by organizing early in advance the capturing of existing data, the segmentation, and the creation of BIM geometry with high levels of detail. Furthermore, the typology of the structures and the respective geometrical data contains material and structural attributes that allow the examination of the level of maintenance. This is the Scan-to-BIM workflow. It starts with a geometrical survey using terrestrial laser scanning through a tool, through Faro focus laser scanner. And then this data is registered, the point cloud is registered within Faro scene. After the point cloud is exported, it is cleaned using Agisoft Metashape, and then the point cloud is segmented using Cockroach plugin within Grasshopper. After the segmentation, there's an algorithmic process in Grasshopper plugin in Rhino and Largebox plugin, which starts with the detection of boundary points from surfaces, the creation of section curves from the boundary points, and lofted geometry from the curves, and the creation of a closed BREP 3D geometry. And this 3D geometry is basically synchronized with a BIM database using the Rhino Inside Revit plugin within Autodesk Revit and Grasshopper. The BIM attributes include the existing material, the volume, the cost per cubic meter, and cost emission calculations. Also, the attributes are processed, as I said, in Autodesk Revit using the Hawkins-Brown emission reduction tool with a material library that contains data from the Bath University Inventory of Carbon and Energy 2011. The existing timber structure is classified according to a predefined ID for each timber element. This is the case study that is made in Cyprus. This is St. Nicholas Church. It is a church built in the 16th century and is located in Galata, which is a village in Solea Valley, Cyprus. The building is a single nave chapel with a gable timber roof structure. The internal width is 3.6 meters and the length is 7.11 meters. As you can see on the image on the left is the church, and then on the right, you can see the existing timber roof construction. Number 1 indicates the rafter. Number 2 is the rafter tie. 3 is the ridge. 4 is the wall plate, and 5 is the batten. As I said, the terrestrial laser scanning survey is made inside the church in order to capture the point cloud data of the timber structure that is visible. Initially, the point cloud is downsampled to 25%, which leads to 16 million points to let the segmentation algorithm to work efficiently. And the first set of parameters provide 499 segments. And this table basically includes the parameters, the segmentation parameters that are used in Cockroach plugin for Grasshopper. As you can see on segmentation parameters number 1, which has 16 million points, the voxel size search and normal threshold degree are defined. The minimum cluster size, the color of point cloud to be true and split true as well, and that gives us the first set of segments, which are 499. And then these segments from this parameter are sub-segmented in order to create groups for each timber beam. So number 2 to 23 are the sub-segmentations, and specifically the rafter segments are identified through settings number 1 to 6, and the rafter ties from settings number 7 to 23. And each parameter has different points, and also there's a certain voxel size search and normal threshold degree that is set so that to achieve the better segmentation. This image shows on the left, you can see the point cloud data that is exported straight from the Faro laser scanner. And on the right, B is the initial segmentation result from parameter number 1. The rafter and rafter ties which are visible from the interior are further processed, and these provide us a total number of point segments, which are 739. Which need to be further classified in order to form groups for each timber beam. The segments representing the timber rafters are baked, allowing them to be easily set in Grasshopper, and the rafter ties are classified using the list item tool. The overall result of these groups of segments provides at least 3 phases of each beam, which are classified as bottom face, left face, and right face. Some beams that are attached to the wall can only provide 2 phases due to their limited visibility. In addition, some other beams were not fully scanned due to obstacles such as the iconostasis, which separates the sanctuary from the nave, and lighting fixtures from the ceiling. So this diagram, as you can see on the left, is the sub-segmentations that are which were further processed, as I mentioned before. And as you can see, the number 1 indicates the rafter, and number 2 the rafter ties, and these are repeated for each beam. So each timber beam is classified to a certain group. And on the right, it's the point cloud, a segmented point cloud from a rafter. Number 1 is the left face, 2 is the right face, and 3 is the bottom face. And I had to classify it into this way so that to let the algorithm to identify which one is left, right, and bottom face to tell to the algorithm. Yeah. This diagram on the left indicates the workflow that is made in Grasshopper for a certain timber rafter. It starts with a point cloud of a beam, and basically the points are exploded to XYZ coordinates. Then the boundary of each cloud is identified using convex hull tool, and the points along with the boundary are imported into patch surface tool for the creation of the beam faces. And then on the image, on the third image, you can see the boundary points and section curves.
basically the bottom central axis is detected and rectangular planes perpendicular to the other axis are formed. The planes are intersected with the geometry of the faces, and the boundary points are created along the edge of the faces. Irregular section curves of each beam are created which follow the geometry of the existing structure. And as you can see, on the faces, these are the points that are detected, which are necessary to identify the geometry of the existing beam. And the lines that you see are the connections of these points that create 100 to 300 section curves according to the type of geometry developed. And on the bottom is the closed BREP 3D geometry created. This is the deviation from the 3D geometry. For the rafters, it provides really good results because the deviation is between minus 7.7 millimeters to 9.2 millimeters. And this indicates a higher accuracy value than the rafter ties due to the efficiency of the algorithm to generate 3D geometry of timber beams with a rectangular cross-section. In contrast to this, the rafter ties had lower accuracy, and the deviation was between minus 88 to 92 millimeters. And this happens because their cross-section is octagonal rather than rectangular, and the generated geometry is simplified to a rectangular cross-section. The synchronization of these 3D data created is synchronized within Autodesk Revit using, as I said, Rhino Inside Revit plugin. The geometry direct shape is used, and also the category is defined, which is structural framing, the 3D geometry, and the corresponding material. And the material that is used from the HBIRD library is HBA wood, softwood, because the existing material is pine timber. And furthermore, an ID is also set for each beam. This is the geometry that is automatically generated and is synchronized within BIM software. On the left is the top perspective view, and on the right is the roof plan. And as you can clearly see, there's some irregularities detected due to the architecture of the building, which is a heritage building, and usually these buildings have irregularities. These are the BIM attributes from this process. On the left, you can see the ID that is defined for each beam, the material, and then the volume is detected, the total cost per square meter, and the overall embodied carbon sum. And in total, the beams are 47, but eventually 11 out of these beams the volume of 11 out of these beams could not be calculated due to scanning issues mentioned previously. In conclusion, preliminary results derived from Scan-to-BIM approach show great potential for its effective application in digital reconstruction due to the low deviation values achieved. The evaluation of average deviation values that range between minus 7.7 millimeters to 9.2 millimeters for the rafters indicate that the 3D geometry is highly accurate and close to the as-built geometry in case of beams with a rectangular cross-section. In the case of rafter ties with octagonal cross-sections, the average deviation values that range between minus 88 to 92 millimeters show that further investigation is necessary both in scanning and in 3D modeling stage. The automated transferring and synchronization of 3D geometry from the parametric environment to the BIM environment provides a platform for data development that can lead to further processing. The potential for calculating CO2 emissions along with the corresponding cost for each timber beam provide us with BIM attributes that allow decisions to be made as regards the preservation, recycling, and reuse of existing timber elements. Future studies may include additional laser scans in the interior of the church in order to capture the missing volume of the geometry from 11 beams that could not be calculated in BIM, and further laser scanning could be done on the exterior of the church for achieving the generation of 3D geometry of more timber structural elements such as the ridge, wall plate, and battens. Further research is also necessary for a much more detailed result for the rafter ties that contain octagonal cross-sections. And I think I'm done. This is, thank you for your attention.
Thank you. Thank you. Now we will start the discussion and questions. Yes.
Thanks for your presentation. Did you think about the interlocking joints between the beams element? I mean, the joints between the elements. How does the different joints is going to affect these numbers you showed?
Yeah, as I said, this is an initial process. Only the rafter ties and the rafters are identified because are visible from the interior. So they could be processed. In order to also find the joints, I have to do a scanning on the outside because I can show you an image. I don't know if... So as you can see here, on the top is the ridge. So this ridge is visible from the outside, from the exterior. So I had to find the cross-section of that and then generate that geometry, and then it's going to be connected with the other ones. The same with the wall plate, because it's not visible from the inside. It's visible from the outside, so the same happens there. So if I have this, then on beam, this could be connected.
Thank you. Next questions. Yes.
Hello. Thank you for the presentation. I missed the start a little bit, so I didn't know what you really focus on. Is the CO2 thing the main focus, or what do you want to achieve with it?
The main focus is basically mainly the creation of the automatic generation of 3D geometry from point cloud data.
Okay.
Which is
then I understand, because in this case I was wondering if it is necessary to have so much precision, because you could just imagine that, okay, these beams would be of similar size, and as long as you have the number of that, you can have a rough calculation pretty quick about, and many of them probably are the same size. And it doesn't really matter if on the fifth comma there is something different. So I think, but to show the workflow, it makes sense. Yeah, I understand that.
Yeah. The aim is to identify also the irregularities of the geometries, because at Tilt, it's a heritage building.
Sure.
Yeah,
because wood and old wood, is never the same. But it depends what you want to have as an outcome.
But the rafter ties have different dimensions, but not that much, as you said. But there's some changes on the volume and
Yeah, but okay, it's a question of how many numbers behind the 0 point it really matters. So, but therefore I was wondering, because but it's an interesting workflow and it might be usable for a lot of things. Thanks.
Thank you.
Thank you for the presentation. It was super interesting. And now, after the workflow is created, I was interested in how much user workforce is required to put. Is it already scanning and then uploading the file and you can get the result? Or you have to intervene somewhere in the meantime? I mean, in already done workflow?
Let's go to the... So what's the question again? Sorry, because I just put the workflow. Yeah, let's see the workflow.
Where the user, like the final user, I know that to create the workflow, your ideas had to be translated, but now the final user, where does he interfere with this workflow?
Okay, so you mean if there are many users through that workflow?
No, you have the scanned point cloud.
Yeah.
You upload it to the script.
Yeah.
And do you have to make some interscript actions, or you just get an answer in form of BIM file?
Yeah. Okay. The points are within Grasshopper. As I said, they are exported into coordinates. So these coordinates are on each point of the beam. So the coordinates define where the beam is placed. And then according to these coordinates, as you can see on this image, each face is created separately. The boundary of each face is detected, and this gives us the edge for each beam, and sections are created basically on the beam, and this provides us with the points on the edge. So using this workflow, you can have the whole beam and also the irregularities, because each section is different, because it's tilted. The beam is a bit, I don't think, maybe it's visible from the geometry as well. So that's how it works basically, and the lofted geometry is created.
So it happens automatically from point cloud to close geometry.
Yes. You put that. Yeah, it happens automatically. Yes, as long as the algorithm is done correctly. Yeah, there's always changes that need to be made. Obviously, there's some, because the point cloud is too heavy data. So, but yeah, it worked. I tried it for every beam, and it worked.
So when you have the point cloud data, then you have to manually somehow adjust it and let's say make it not so heavy so the algorithm can work it properly.
Exactly, yeah. What has been done, as I said, the point cloud was downsampled.
Yeah.
So the initial points were around 64 million. So only the 25% of these points are used, because then it would be too heavy and the algorithm wouldn't work.
And when you showed us the different sides of the certain beam, you need to define those sides manually for it to work, or the algorithm somehow can detect that this is a beam and it has 3 or 4 sides?
Yeah, that's a good question. Right now, it's, as I said, on left face, bottom face, and right face are defined manually. They are like set, the cloud is set manually. But obviously, it's a good next step, let's say, to use maybe machine learning or these processes to detect the phases automatically.
Okay, thank you.
Hello, thank you for the presentation. And I would maybe ask, like, in this process, you were talking about this specific case study about the church.
Yeah.
So if you think like to apply the same method on different place, do you think it is like general way that would work for any other similar structure, or is there something specific for this church that you considered?
Yeah, good question. The aim is to apply this to different types of architecture as well, to different types of timber roofs. That's the whole point, to apply it, to try it into different types of architecture, not only this, but other churches as well.
Yeah, thank you for the presentation. I think you just answered my question. But to extend that was also, so your intention is also to create this for different forms, right? Or because now you have the 3 phases. Are you intending to try to create a similar script for other forms?
Yeah, the timber rafters have an octagonal cross-section. And a challenge is to also manage to identify different types of cross-sections, not only rectangular. Yeah, it needs more developing to do that.
Okay, thank you very much for your presentation. I'd like to ask you about these cultural heritage issues, because we can say, okay, there is a lot of numbers after comma on one hand, and on the other hand, what is the approach in Cyprus to cultural heritage buildings and replacement of elements? What is the old school, new school? How do you proceed? Are you very aware of detailed sizes of original elements, or because it is kind of a purpose of this work, I guess. Yes, you have the structure, and maybe it needs maintenance, and then your work is well, perfectly useful for that. But do you know what is behind it? What is the?
Yeah, definitely. There's many buildings in Cyprus that need to be refurbished. Especially their timber structure, which timber is a very sensitive material, and through a process that is more automated, you can analyze the existing material in a better way, because heritage buildings have all these irregularities and sensitivities. Also, through laser scanning, you don't need to disassemble the building completely. Like you don't. Because there's rules for heritage buildings that you don't need to touch this, touch that. So through using just your scanner and getting the data, you go back to the drawing board and you analyze it, and you sort of make decisions either to replace a certain timber beam, maintain it.
Right,
Yeah.
so let's go with this replacement option. If you have to replace it, what would be the new element? Is it like resembling in totally detail what was there?
Yeah,
like
it should be,
or
the new element definitely should be the same material. If it's pine timber, specifically that timber is from the surrounding area, so maybe it's better to use the same material from the surrounding area. Yeah.
Yes,
same
but what
size.
about sizes? I mean,
The size
yes.
as well. If it's important to use the same size, then
Yeah, but maybe I'm not putting my question right. Let's go for an example. Examples from Poland. So this like old and new school, and a lot of schools towards this topic. But generally, the people who are in care of old buildings, they would not like new elements, like brand new from CNC machines, to be put there. On the other hand, we may discuss that, okay, this structure is kind of regular, but you discovered that each rafter is a little bit different, yes? And does it matter or not? Was it just because it was handmade, yes? So kind of a human, let's say, capacity to make them as the same as possible at that time, or maybe it was like a climate, moisture, etc., that changed these beams, these elements, slightly over the years or decades or centuries. So if we have such case in Poland, that is a huge always discussion, what to do, what to replace, and how to replace it. So, so if these, as I said, these values after comma matter or not, yes, to make the element that you are replacing totally the same or similar.
Yeah. For example, this rafter tie, it was sort of sculptured, as you can see on the center. It is sculptured with Byzantine methods, sculpturing wood. So let's say that beam is destroyed for certain reason and it needs to be replaced. The best way, I believe, is to find someone who can remake it, either by hand, obviously, but if that's not possible, then you can scan it in much more detail and then process it so that you know the geometry and recreate it.
Okay, thank you. Thank you very much.
Okay, any further questions we'll have to make during the coffee break and the lunch, as we are kind of behind schedule. So once again, thank you for your presentation.
Thank you.
And thank you for the amazing discussion. So I would like to welcome the next presenter, Mr. Michał Jarzyna. Big round of applause. and the stage is yours.
And the mic is there. So again, good morning everyone. My name is Jarzyna and I'm from Łódź University of Technology here in Poland. Today I would like to tell you about my research of use of BIM model in outsourcing facility management services, which is kind of my side research of my main bigger research on routing in BIM, supervised by Professor Anetta Kępczyńska-Walczak. The topic consists of three main ideas: BIM, outsourcing, and facility management. And the goal of this research is to find kind of a common ground between those ideas in order to enlarge the circle of possibly interested parties in having a post-built BIM documentation. So, to start with BIM, as it's a vast concept, obviously, in terms of facility management, I'd like to open the back and underline two ideas. The first one is IFC, the standardized file that makes it kind of independent of commercial software, and that the facility manager, the owner of the building, should at the beginning, at the start, require having the IFC file that makes him more flexible in terms of choosing the solution. And another idea is level of detail that describes how, in which stage of detailment the model is. Ideally, the model would be LOD 500, which stays for as-built building. But for the most of the users during facility management, level of detail 300 is quite an enough solution because it consists of the geometry, orientation, amount of elements, and also some required spacing all around. So it will be enough to have it in LOD 300. Another idea is outsourcing. I'd like to define it at the beginning because even the picture here can be a bit misleading, because having like an internet connection on or mobile telephone services in a company is not outsourcing. Outsourcing is when a supplier and a client enter into a kind of arrangement to have services that customer presently hosts internally. So the main reason for outsourcing, naturally, it's reducing costs, as always. But some of the reasons that also are quoted are mainly about the flexibility to answer to market, changing market, to some organization changes, and to focus on the main core of the business, of the facility. So, as I said, the things to outsource are not that obvious, and they are highly depending on the company, but some of them are the most popular, like marketing, accounting, tax compliance, and facility management. What brings us to the third topic, and I like to also define it in order to find this common ground. So facility management is about all of the activities of the company, of the business, that are not related to the core task. So if outsourcing is about getting rid of the tasks held internally, and facility management is about getting rid of the tasks that are not correlated, then the common ground appears. Facility management is also a vast idea, starting from such an obvious solutions like maintenance, but also some resource planning, mid-term, long-term resource planning, alteration of the building, and also some nicer elements like catering, employee special services, whatever it is, and even child's nursery to be held by facility managers. And when we compare it with the fact that the post-build life cycle of the building generates such a huge amount of costs, then there is definitely a way to optimize it, to use the technology to make the solution cheaper. So when we know where this mystic common ground is, now let's see how to use BIM model to improve the outsourced facility management services. To start with some examples, when you have a well-maintained, well-prepared model, you can easily order some interior design, some remodeling ideas, because you already have the part of the documentation. It doesn't have to be recreated, so you're optimizing the costs, naturally. When the information about the space, when you possess it, you can use it for location searching, for finding elements, for connecting points, finding the route between the spoiled element, between storage and distribution place. Imagine the situation. You want to outsource the tasks to help some failure of air conditioning unit. Of course, a company from the outer comes, it may be a completely new person, and when making an order for an outsourced task, you can, with the use of BIM model, provide the order with a map, so the person can easily find where the unit is. He doesn't have to be hosted by an internal worker, so the worker can focus on the core task of the facility. So routing with the use of BIM in facility management definitely also can optimize the processes. When the failure happens, before a serviceman comes, some repair request has to be made. So also using BIM model, you can manage those requests using, like in Dialux, you can using QR codes to gather the failure information, put them in an order, and to have the maintenance plan in terms of distance, in terms of importance of the failure. So still, BIM model. When routing is concerned, also some fire safety issues comes. Naturally, you cannot make it on your own. It has to be made by a professional who is entitled to do that, and of course, like signed, stamped, but still having some kind of spatial information can speed up the work and save the cost and lower the cost. And going level up, not only just like simple pathfinding, but also in the future, hopefully, legally it would be also regulated to use agent-based modeling. Still, you need some information about the space. Why not to use it from BIM and then outsource the task? Of course, environment issue also appears here. Let's say we have the BIM model of the building. A company from the outside has the model, and the task of the company is to constantly analyze the model according to changing technologies. What will be the cost of building process to update your facility? And when the gain-loss balance speaks for the gain, then you can easily enter the technology, use it, and with BIM, those analyses are almost automatic. So they are much faster. And then the answer to the changing environment, market, is also quicker. When any kind of management happens, in kind of maintenance happens, then you have to manage also your spaces, relocate the activities. Why not to use BIM in order to gain the information where you can relocate the area according to some of your needs. I want to be up to date. I've checked recently that still there is no way that BIM can take care of child's nursery. So hopefully someday, but now I will skip this one. And proceeding to the last one, when talking about all of the outsource BIM tasks, a need for a new service emerges. And this service is converting two-dimensional documentation to BIM, updating your current BIM documentation to the demanded level of detail, or when you've done any of the changes in your building, updating the BIM model for the building. It's also like a documentation management task, can be held internally, but you can outsource it to another company. And that's all what I've had in mind, and I would be glad to listen about your ideas of how to outsource BIM.
Thank you, and now we will start the discussion. Any questions? Yes.
I have a rather general question about your research. Are you developing a kind of a conceptual framework for using BIM in facility management, or based on this you are going to develop the usable solutions, let's say in maintaining the interiors and so on?
The goal, almost achieved, like super close to being achieved, is creating a solution to use the IFC file, so like an open source text document, in order to proceed it, the user is able to find the shortest path between points in the building, and the tool, the research practical element, because I'm also a fan of practical implications of research, and the tool can give the answer in form of graphical information. So then it can be an attachment to outsource order, how to get to the point.
Thank you.
Thank you for your presentation. I'm not an expert in facility management, but I think when you showed the overview of all the kinds of services that a facility manager has under their command, let's say, that first of all, it's not one person or one company that covers all the facilities. It will probably be multiple companies that do part, you know, of the cleaning, the maintenance, the childcare, as you mentioned, catering, stuff like that. So these are multiple companies that take care of that. And I can imagine that currently these companies are also using some kind of software for planning. So are you looking at these softwares as well to see if you can make a bridge, or maybe they already solved part of your problems? And are you looking at, okay, maybe I can do something better, more clever, more efficient? Yeah, so in what sense are you informed from the facility management side?
As I've looked for, I haven't found the tool that integrates the BIM IFC information with the use of facility managers, because facility managers, of course, they have their own software solutions, but in terms of building information, they mostly based on two-dimensional PDFs, and that's all. That you can open it on your computer. That's of course a plus, because you don't have to roll out the paper. but still you look for the element manually. And the idea is to make it kind of independent of these highly priced commercial solutions to manage BIM files. That's why you need an IFC file because of course, when you are a designer, you need Revit, for example, or ArchiCAD. But when you're a facility manager, you don't need to buy all of these tools to manage your files. So that's why I think that there is a place for optimization and to connect those branches of the facility management.
Thank you. I want to ask you about how you relate this one with digital twin of a building modeling. As maybe you haven't mentioned in the process here, but I'm just curious about it because I'm also working with that one. So how you relate with digital twin of a building, as written here?
Could you please repeat the beginning of the question? Relate what with what?
In the abstract, it's saying having a digital twin of a building also comes with such responsibilities as the need to constantly update the model and to keep a minimum LOD. I want to ask you, are you also looking to the direction of digital twin modeling of building, or it is just building information modeling? I'm just curious about it, because as written here.
The part that you've read is about the last slide that I've
maybe I missed it. I just
that I've mentioned that when you want to deal with BIM model as a facility owner or facility manager working for a facility owner, there will be some changes. You may need to start your BIM process. So I think that the need for the whole, a new idea for a business, a company, to convert the documentation, to update the documentation, because naturally when you're a facility manager, you will not, as I said to Henry, you do not buy a Revit in order to move the wall if you've rebuilt it. You will outsource this task to another company that will have to make it. So this is one of the branches that can be used potentially.
Okay, thank you.
Hi, thank you for the presentation. My question is about outsourcing generally, because once things are being outsourced to other companies, it also creates several strands of information. So it's not standardized often. So my question is how it is here in Poland. Is there standards for IFC models, and how would you make sure that the information you get back would be usable?
The IFC models are not standardized by law. I think that they depend on the IFC, this organization of open something. They depend on their standardization because they are
building smart, yeah.
Yes, exactly. They are updating their requirements about the IFC, so hopefully it also will be legally regulated to have the IFC file according to the exact specification. So it will combine, it will correlate with the information. So sadly, it's not, but I think it's not only a Polish reality. Generally, I think that Nordics are regulating it somehow, that the BIM uses. UK, I've heard. In Poland, it starts to be required as a BIM use, but still now it's like a BIM documentation, not strictly. I think that the perspective of use during facility management is not that seen and noticed now. Hopefully it will be soon.
If I can ask a question, do you see a possible open library of all the buildings participating in the program of outsourcing in terms of the IFC files, as in more of a platform for legal tenders to access information regarding certain buildings, or is this more like singularity, so business to business, relationships between the IFC file and this one company that would represent the given building?
I think in terms of kind of privacy and generally information about building, it's not that safe and a good solution to publish information about the building, especially when we're talking about like governmental buildings or bigger facilities like shopping malls, stadiums. So you don't publish it, it's your private, hopefully secret information, and you just publish and exchange a piece of information. So you're a possessor as a facility manager, you have the documentation, and you're just like an API. You're just sending a piece of information that is needed, but not the whole thing, I think.
Okay, yeah, thank you. Yes, so thank you for the discussion. And next on stage, I would like to invite Mr. Emir Isik. And, Mrs., I'm sorry. All right, so the stage is yours, and this is your microphone, yes.
Thank you. Okay, thank you. Okay.
Or you can use this.
Okay. Hello. Okay. So today we will look to the fetal child and adult physical and digital twins in design process and through the hybrid prototypes. I mean, it's a little bit confusing, maybe. Let's see. And I'm an architect, by the way, but some areas like urban design also. I had several experience on healthcare projects and some education projects. Now, currently, I'm working with Professor Dr. Henry Achten at Czech University, and we are looking to the digital twin studies in the field of architecture and theory of design. So, we will today look these 5 main issues, like the problem and hypothesis and some digital twin technology information, and what is the point why I am doing this one. Yeah. Okay, let's see. Do you know digital twin? So what do you think it is? It is kind of a thing. Maybe you can also answer.
About all of the processes that are happening in the building. So I think that digital twin can be a bit misleading, that it's not like a solid information. It's also about processes and this soft thing.
Yeah, right, almost. So thank you. So let's see. I mean, it is correct. I haven't. So it is actually common in the industrial areas, mostly engineering part of it. It dates back to the NASA's NSA studies, the aerospace. But nowadays we also see this one in design processes, like product design, with the help of the advanced sensor technologies and computing. Nowadays it's an issue with maybe in architecture also. So what is it? It is actually we have physical twin and we have digital twin. But they are not a 3D modeling of something. There needs to be something like the connection as well. So here the part is the connection is important for us to understand it. It is not directly 3D modeling of something. We need a data connection with it. So I think it is important because we read the physical twin, then we fit our system in digital world, but it is happening simultaneously, at least the goal, But nowadays, generally, people also can think about this is directly 3D modeling. Okay, why I am looking that one as an architect, I am not sure, maybe I am crazy. We can see this one used for product design, engineering use that one, test and build their digital twins, and then suddenly they have a a lot of simulations, and they found the perfect solutions, maybe this Michael design in the Tao explained. And this is the prototype design. It is more like, can be linked to the architectural one, so we can test our digital twins and we can do simulations. At the end, we can be happy. And this is the like building design in the bottom part. It is in China. According to their research, they already done digital twin of building, but it is like they generate the process of it. So let's continue. Why we are looking this slide? Yeah, this is like architectural models because I'm an architect and I want to combine this digital twin issue with architectural way of it. So by looking that, we see here like models, prototypes, mock-ups, and prefabrication. These are the like things that we can build as an architect. And prototyping is kind of activity to define the process and to find the perfect solutions maybe. So we are assuming like if we add physical models, the part of like digital twin integration, it can be called like hybrid prototyping. So each of these parts of the building model, like prototypes or like prefabrication of the window, can be helpful for us to understand digital twin even more or like integrate that one. So each of the models will offer us some more details regarding the architectural process. Do you have any question? Like, I am going fast? No, okay. So, we like, yes. Okay.
We're a little bit worried. Yeah.
Okay, so it's better. We cannot focus, you know? Me too. So we hypothesis like Foetal child digital twin may be stand-on for this issue. So what are they? There is one researcher, Raphael Sachs, also working with building information modeling in Israel and England. He proposes something Foetal child and adult digital twin in the process of building like construction from design to operation. This is like kind of a like it's development of it, like the process, digital twin included in their research. So we are actually looking that one as a base, like these are the progressive states of digital twin. So we took this idea and tried to implement them with prototyping. Why prototyping? Because there is one point you need to understand. If you want to have real digital twin, you must also have the physical twin. It's not just like digital twin itself. Like until the design process, when as a designer, when we have the prototypes, we can then start to talk about digital twins. It's not like from the beginning. So that's why we create this like hypothesis, try this hybrid prototyping, this Foetal child digital twins. So Foetal one is at the beginning of the design process, like the tiny Foetal and trying to improve itself. And child one is again in the process, but nearby to the more construction site, not at the beginning of the part, but the adult one is the completed version of the digital twin. Like this can be like adult digital twin because it is already in operation. So we can collect all the data related to it. Okay. So in this process, there are like hybrid prototyping process. My focus for this research today for you to highlight the processor, actuator, and sensors. This is first step while we are building the digital twin. Let's see how we do it. So here you see 5 stages of digital twin, and it is like a big umbrella term inside of everything. And the first step is like you need to obtain the data from the physical environment. Like you have a lot of data sources like weather, energy, whatever you wish for. So then you need to transmit this data to your modeling. So you need a network to do that. Like so you need to transfer it. So when the third stage came, you need to build the digital models. Like you can do a lot of modeling issues, like city, building, like asset or agent-based models. It is up to you as a designer which point you want to focus on. So you cannot build all the details, yeah. But the fourth part is then when you have the model, but you need to integrate this model and data, everything should be integrated in the system. So here you need like data analysis, actually, not an architect. So also you need to visualize your data and you need to use artificial intelligence algorithms like machine learning. And then at the 5th stage, you have the service layer, like this one, like we are operating and we use the space. So it is delivered to the people or the user or the facility managers. Like this one, like this is the digital twin, how you can build it. So it's like huge, complex idea. It's like the study from England, Cambridge University, they are studying right now, they have a lot of research. Okay, so you see, we will try to look the first layer, because I cannot look all the details right now. So the first layer, we are starting with collecting data. That's why we are seeing me, you are seeing me right now, okay? So, and this is the tiny thing, as an architect, maybe we should remember, because when we look to the like studies, we cannot see directly architects can use digital twin in a way that like that, but first, I need to know what I want to collect from the digital twin. What is my like scope? I need to understand and try to choose the right tools at the right time, as you mentioned. And so we need to know where the sensors should implement at the beginning if we want to achieve this one. Like we cannot collect data after we build, you know? It will not make any sense for design process, I mean for the operation, yes. And so we will have a clear plan to collect the data in a right way, in that way. So as an architect, we can build a digital twin team, maybe we can set some goals, so try to understand the issue. So what I did, I just tried to first understand the issue, what is the digital twin, as you have seen before, and now how I can integrate this one with design process. So we mainly look to the design, basic design cycle, the Rosenberg and Eccles, like 1995. We took that one and tried to implement this one and this one in a one framework, try to understand as an architect. So when you look at one, we have again the same 5 stages. We are trying to look in a basic design cycle. So these are the steps. Like you first combine the analysis and build this one, data acquisition, like it is a huge layer. And then second, you have the criteria, synthesis, or digital modeling layer. And third one, in my case, it is more relevant to the architectural one. Like we are starting to build prototypes. So simulation also will be integrated. So this is the point. So like at the end of stage, you will have your build or intentional building digital twin, so you can give a value for that. So what I did, or what we did try to understand, the first one, what two designers want to accomplish this digital twin. And then secondly, is there any alternatives to do that? So then, this is also like basic design, something from the Norman use. So I try to combine these design principles to that one by looking the process in itself. The third layer, so we are like building the models and try to give the meaning of it, like what action can digital to do now, and how does it can do that. So the fourth layer, we are just looking and we have the dashboards and what happened with this digital twin, we need to understand. And the 5th stage, like, am I satisfied? Like, is there any real value to do that? Like, we cannot build everything in digital twin. So at the end, we will have our adult digital twin or physical twin. So until now, you have seen the processes that I come through until now. And today, my main focus to create some kind of digital, for architect, design catalog, how we can start to see that. It's like new thing. So first, as an architect, we need to understand this perspective, and we need to understand IoT, like Internet of Things, to do that, and we need to apply this one in the process. So not just like the materials, also building behavior, as Henry also mentioned many years ago. So while we will do that, I think it will be end of the day sustainable issues, like the goal, like we will, because understand the building itself with a lot of stuff, then we will try to create some sustainable solutions for our designs. So here the data collection and synchronization is important, and the evaluation of the meaningful design also is important, and we need a concrete data. So we need sensors, we need engineers to do that. Okay, this is just like a proposal. If you're more interested, you can also check the paper. Like, as an architect, this is not new thing actually, but the new thing is like, as an architect, how we can do that. Like, we will define the sensors, which sensors where need to be, and is it like sound, or for air, or for wind, or what is the design criteria here? So to do that, we will look fetal, child, and adult digital twin in the process. So for this one, we will try to create kind of sensor lifts, not as you see here, acoustic, comfort, air quality, soil, specialists, and whatever you wish for as an architect. And what is the conclusion? Okay, before conclusion, I must admit, this is the process. Now what I'm doing, we are now have a tiny model to understand how I can implement as an architect this one. And we have some sensors on it, it's really tiny, but it is challenging. Now I am at the stage of trying to collect the data from the real environment, from the physical model, and collecting this one from Arduino and transforming C# programming. Now it is the stage how we can collect this one, we need to collect this one as historical timeline. So it is now at the stage SQL, we need a database for it. It's like a kind of starting point of view. So why I did that? Because of it. Because I now have the sensors in my tiny model, so trying to make an architectural view of it. So at the end, it will be helpful to involve hybrid prototypes, trying to think about sensors. So at the end, it will be benefit for the design process, and as an architect, we can maybe build sustainable solutions, and we can find a way how we can look to the design even more before, I don't know. Yeah, thank you. And if you have any questions, please, you can just write me.
Thank you, Gulbahar. Now I would like to start the discussion.
Am I bored your mind, or it was not unnecessary to speak?
So thank you for your presentation, Bahar. It was really quick, so I'm not really sure I understood everything correctly.
Okay.
But maybe I would like to ask one thing about, you were talking about digital twin during the design process. So what is actually benefit, how it can help us to start to develop from the beginning of the design process? And then maybe also in a relation with facility management, that was the previous presentation. So maybe we can imagine more benefits to use it later as a facility management tool. And also maybe I would like to ask you about what's the difference if we use a digital twin for a new building, so we think about it from the beginning of the design process to start developing the digital twin. And if we consider creating a digital twin for a building that is already built, but we don't have a BIM documentation for this, so if it's possible and beneficial to create such a model.
You have 3 questions, I guess, so I will try to reply that one. And the last one that you mentioned, actually I am trying to looking not the finished building, I am trying to looking at the beginning of the building. So why it will be important, as an architect? It will be beneficial if I understand what kind of energy this area will use, or how many users will be included in this area, or how many wind this will forcing this maybe this window size, or how much light will be passed through. All the details that as an architect we are supposed to know, the issues like light, sound, blah blah. If I know at the beginning of this one, so I can maybe work with in the digital twin system, with the managers also, we can cooperate at the beginning. If I don't know anything digital twin, or what kind of sensors should put where, I mean, as an architect, it will not make sense. It will be just you will read the book and try to do that, But nowadays, facility managers generally use digital twin, not in the design process, after the operation. So this is the one point that are missing as an architect. So second question was, maybe I haven't answered that one.
Yeah, it was just about the new building and the existing old buildings. But
the first one?
And the first one was about the design process and the facility management. So I think we
almost covered. Thank you
for that. And then another one, I would be interested in the tools, because are there some tools you can use nowadays for creating such a model, or it must be every time a combination of different tools? If you can have this one source of the truth in one tool, or you need to combine it somehow?
There are a lot of dozens of tools, but you need to understand which tool you need. But for me, C++, Sharp, and Arduino is the best and easiest way to do that, to collect the data from the reality and transform this one to the physical, to the digital version of it. But there are a lot of tools, like, you know, not C, just SQL or C++, like maybe, okay, I just need to remember my notes, or maybe even more. Let's see. Like, I mean, engineers use a lot of dozens of stuff, but I focus this one because I have a kind of like technical advisor from outsider who is a mechatronic engineer, so, you know, it is all process, so for me, the best way to do that, to like achieve, how I can achieve digital twin building. You know?
Okay, and there is some live connection between this Arduino and C# stuff and the
yeah, because model. It is the easiest way, like in my point of view, to collect this one and try to see in the system. Like, I mean, if I am working with another electrical engineer or whatever stuff, I can collect a lot of data related to that one, and I can use like SolidWorks, but I will not use. But while they are doing this research, they use like a lot of part of it. So like each side of the part, like city building information modeling, now they are doing in Cambridge, is like related to a lot of parts. Like a lot of researchers included it, you know? So they use a lot of simulation tools like maybe SolutionWorks and BIM. Also that, in my case, it is BIM. But there are dozens of modeling tools and also collecting data tools. Not that, or Arduino, but it was like accessible one for me to do.
Okay, thank you.
If I may ask a question, do you plan on perhaps integrating some kind of online virtual societies, social platforms for building, testing, and implementing experimental functions for existing buildings with the digital twin?
In my case, I am not looking in that direction. Already somebody looking at the existing building and trying to collect the data. Like in my case, I don't, but if I have the digital twin data catalog from the like a lot of Foetal twins maybe, it can help me to implement this kind of, because in digital twin you have the different version of like digital twins, like not just one, like a D2, 1, 2 until the end. So I mean, in my case, I will not look. I don't have any intention to do existing buildings. I want to look to do how we build and how we use data. But first, I need to understand, of course, the real building as well.
I have to admit, I'm a little bit lost now.
I know. Me too. I don't know what I'm doing here. So.
Okay. So what I didn't really get is when it comes to digital twin and a physical twin in the design process of a building. Mm-hmm. So you would need to have a prototype of the building.
Yeah.
How do you do that?
Actually, we don't need to do that. Already architects doing this one like many years. You know, prototyping for architects. There is one book. A lot of architectural firms already using prototypes. Like in a way, if I wish to integrate that one to real prototypes, it will be more meaningful. But I am starting from the scratch.
But you're talking about sensors at the prototypes and stuff like that. So we need to get rid of some buildings there, build our prototype, put the sensor in, and then go on designing our building?
No. Okay, let's how we do that. We will not go anywhere because we already have a lot of prototypes. So we know the strength of the material. We know maybe the needs for the...
Okay, so elements of the building.
Yeah.
You're testing elements of the building.
I cannot test everything. So that's why I just took this one, because I need a physical model to that.
Mm-hmm. But there was a whole building there. So.
Which one? Of course. It's like tiny cube that's trying to impress the feelings that we have for digital twin. Not feelings, I mean the, like cube. It can be everything.
I was curious for your tiny model, about your tiny model of the building. You placed already some sensors on it, and which sensors you use and why?
Good question. These sensors, that's why I try to combine everything. This one? Yeah, these are the sensors, but these are like acoustic comfort for sound sensors, and the second one for air, gas, pressure sensors, wind sensors, like conductivity, but I don't care. In my case, it's not important. Maybe it will be important if I integrate this one landscape also as well. But it's more general looking of doing that. And if I want to collect the data related to occupancy, like I need occupancy sensors to do that. And touch sensors maybe, but in my case, I haven't put, I have put there PR, I guess, like the sensor for your touch, and then system is functioning. Yeah, I have this one. Humidity, yeah, I have also this one, and lighting. Yeah, the things that you need to understand as an engineering, not direct engineering, what is the call? The Department of for Architectural Design, they teach building, climate, things, yeah, that one.
Okay, so most of the sensors are related to, let's say, weather and physical environment of the site. What for do you use those touch sensors? What are they measuring?
If I want to work on interactive architecture, like, I mean, if I have a kinetic system, or if I want to understand the material itself, maybe it will be collect my heating data. It can be also important. So if I use that one, it's like touch screen way, or there are a lot of potentials. To be honest, I haven't directly looked at one of those because I am like, until this now, I came this far, you know. I haven't decided, to be honest. Like, we will see.
And for how long do you think you need to collect the data on the site? Because during the year, of course, the conditions are changing, and even every year it's different, right, on each site. So how long do you think you would need to collect the data on each site to actually get some solid results, which you can then apply into design?
I think it is also needs definition, but now in my new study that I am trying to create a full paper, I am looking on that way, so it will be more accurate to answer that. To be honest, I don't know. We can collect according to the needs of the space. We need to know when will we implement, or what will be the case or the focus of it. Does it make sense? Because I'm not engineer, so I don't know right now.
Okay, are there any more questions? Then thank you for the discussion. Big round of applause. And at this point, we are finishing with session number 3 and beginning with session number lunch. So I would like to invite everyone to the lunch area and to continue discussions regarding the past, present, and future presentations. Thank you.
We're about to begin the next session, and before we begin, I have a kind of announcement or a proposition. The issue is that a few Polish technical universities are preparing a project application to the Horizon scheme of European Union, and I think maybe some of you will be interested in discussing this. And I will ask Bartosz Czarnecki, professor. He's a head of research at our faculty. He will tell you a few words about it, okay? Yep.
Thank you. Hello. I'm the head of urban planning, spatial and urban planning division here at the faculty. With us is here present Professor Krystyna Januszkiewicz from West Pomeranian University of Technology in Szczecin. We together have idea to applicate to the, as Adam said, the call for projects from Horizon Europe. The how to say, the general topic is climate change mitigation for modernization or restoration of urban areas using green infrastructure, green engineering. So we're trying to we're looking for partners. So if you or even your universities have experience and or it is suitable for your area of interest, digital tools may be useful. So please, during the next break, you will be guided. Persons interested will be guided to meet with us and talk about it. Here is Professor Januszkiewicz.
I am from the Technical University in Szczecin, West Pomeranian University, and we have to prepare an application to Horizon grant, which deal with green infrastructure in the city to mitigate climate effects and these things what we know very well. And I would like to know what is your interest in science, what you are doing in your PhD thesis, what is your experiments in this thesis, and if you like to be our participant in this, this grant. And we will meet you at a number of rooms. Could you tell them?
It's room number 7 in the main building, on the ground floor here. So you can take your coffee and go there and talk about it, okay? The coffee break is at 3 p.m. So within this half an hour, there will be a possibility to talk about it. Thank you very much. All right. So the next presentation, or rather the first presentation in the second session today, is Isik Vele and Henry Achten presentation titled Clay Non-Planar Printing of Overhangs. Wow, yeah. Thank you. Yeah. But you have to be strong to take it out.
Okay.
Yeah, good.
Don't be afraid. Yeah. Hello, everybody. Thank you for listening to me, hopefully. I have a topic called clay non-planar printing of overhangs, which is part of my PhD research under the supervision of Henry Achten. And I am sorry at the beginning for naming it such in a cryptic way. So I did a spoiler, and on the second page of the presentation, there is a direct outcome of the whole paper, where you can see that this is an object 3D printed out of clay, and the layers are non-planar, and that means that the layer height varies through the whole object. This is a great advantage compared to the normal, regular 3D printing, because when you are printing in a normal way, you have each layer at the same height, and sometimes that's limiting for the object, whereas here you start as a flat layer, and then slowly you are increasing the layer height in the middle and decreasing it on the edges. I hope you can see it. Yeah, you can see it. And in the end, you kind of can develop this type of 3D printing where the printer moves its Z height always. So the normal 3D printing is more a 2.5 3D printing, because yeah, you are lifting the Z only when you finish the layer. Yeah, there is some table of contents. So first I'll do introduction, and then the proof of concept experiment. And then we can talk about the future, or I will talk about my future work, and then we can discuss the possible use cases. The whole inspiration of non-planar printing came to me from plastic non-planar 3D printing, where there are very interesting case studies and initial projects. You can see here that the regular FDM desktop printer was kind of refurbished for 3D printing these non-planar layers. You can see that you can 3D print perpendicular overhangs out of plastic in one direction, but also in two directions, which is super interesting. There are, of course, some limitations. For example, when you are printing these steep layers, the print head can bump into already printed object, and it may cause issues and troubles. Also, the nozzle can scratch the already printed material and can accumulate around the nozzle, and then it can somewhere detach the material and destroy the object. So the best thing how you can 3D print non-planarly in every sense is to use a 6-axis industrial robot, where the nozzle tilts to the perpendicular to the layer. If we go further, so I was like, wow, that's amazing. So let's try it in either concrete or clay. But of course, concrete is way harder to print and to experiment with, so we went for the clay at the beginning. We refurbished also the desktop FDM 3D printer. You're gonna see it on future slides. And our idea was that by having non-planar layers of these overhangs, you can improve the clay buildability. So you can build crazier objects, and the layers can guide the majority of the inner stress during the printing into itself, which is kind of interesting, because when you are putting the layers on top of each other, the weakest spot is the connection between the layers. So usually when you, for example, even in plastic, if you print very tall column, it cracks very easily because it's anisotropic. But by having these wavy layers, you kind of morph the inner characteristics of the object. And also, we wanted to reduce stair-stepping effect. You can see here that at these overhangs, the material does these stairs, but with non-planar printing, you can always go perpendicular to the overhang and maintain the resolution of the object all around itself. So we decided to make the set of these vases, and we did 13 types of vases, and each we sliced planarly and non-planarly. And these overhangs started from 10 degrees and ended at 70 degrees. And the goal was to see when the objects sliced planarly start to collapse, and when the object sliced non-planarly starts to collapse as well, and then compare it, and hopefully maybe the non-planar sliced object will last longer. Okay, so it's... here you can see the setup we have, and it's a normal desktop FDM printer, Delta 1, which is very helpful because your print bed stays on one place, doesn't move, which you don't want when you are printing clay. And we created a custom-built extruder, which you can see here. There is a RAM inside, and the extruder from the printer was connected into the bigger motor, which pushed the material through this hose into the print bed. Also, when you are printing clay, it's desirable to fasten the setting time, because when you print clay, it takes 24 hours before it starts to be solid. So you can increase or reduce this time by blowing an air onto the object. These blowers have to be very far, or quite far from the object, because you don't want the pressure of the air to push it down or to demolish it. And the printing itself of those objects you saw happen with a 4 mm nozzle, and the final layer thickness was 8 mm. The planarly sliced object had 3 mm layer height, and those printed non-planarly had to have a different layer height, and at that time you have to change the extrusion multiplier. So when you have a higher layer, you have to extrude more material, and when you have a lower layer, you have to extrude less material. Issue with this thing is that the RAM extruder has a long reaction time. So when you start to push harder, it takes 15 seconds before the material really starts flowing a bit more. So we ended up with a combination of changing this multiplier and also changing the printer speed. So when the printer was printing higher layers, it also reduced the speed. And that's how we achieved somehow the same layer thickness for these non-planar objects. Of course, we faced many issues since we are using only 3-axis printer. We faced the issue that at the nozzle, the material kind of accumulated from scratching already printed clay, and these bumps later got deposited inside of the object, and it caused several ugly bumps like that. And also, interesting thing is that these objects, when printed non-planarly, they have a very large layers here at the top of the object when you are aiming to make the top layer flat. And that makes the upper layers very thick, and a lot of material is there deposited on one side and then on the other side. And the center of the mass is, the object is designed in that the center of the mass is in the center, surprisingly. But when you are depositing such a large amount of material on one side and then on the other side, it slowly starts to bend like this, and then it collapses. So the non-planar prints didn't fail at the overhang side, but they, after some time, started to collapsing because of this uneven material distribution. Okay, when we finished 3D printing it, we kind of looked at it and we said, oof, thanks God, it works. The non-planar printing is capable of printing larger overhangs, as you can see here. This is the 70 degrees of overhang, and the planar print compared to this one failed in very few layers of the overhang. The goal of this whole process was to have the same layer amount on both objects and same printing time, so to somehow really make the experiment viable. Okay, so I can go a bit further. So the conclusion is that the clay non-planar printing really improves the buildability and reduces the stair-stepping effect, because you can print perpendicularly to the overhang and can better reflect the geometry. So if you have some surface, you would like to have a wavy surface, for example, you don't have to print it planarly, where you can see these layers and circles of the increasing layer, and you can print it in one go with these non-planar layers. And I think main issue is that it was so far tested only on a very small clay object. It should be tested on a bigger one and out of concrete. And that's part of the future work, where I would like to use a 6-axis industrial robot and tilt the nozzle during the print, which may even increase the resolution and the outcome. And of course, print the larger objects, because this was just a proof of concept, and the cementitious materials. I think I've skipped one page here because it loaded for some time, yes. This may help for challenges in additive manufacturing, because as you can see here, when we were printing larger concrete objects, it's always difficult to print any openings or windows and stuff like that. So you can see that oval-shaped openings can be printed with a small overhang in a concrete, but here you really need some support system. This is troublesome because you have to have somebody who puts this support system inside, and then the robot may bump into it, and this support system damages the object, which is not desirable. The other way how currently it's being made is that you are printing and pouring some support system all around it. It's small pebbles inside and also outside. But that limits the size of the print you want to print. So if you would like to print buildings, it's not manageable with this way. And that's where this non-planar printing may help, because instead of printing the whole object planarly, you can take only the top part and change the layers. So up here, it's planar, and here are few layers non-planar. And by doing so, you are reducing the necessity to use the support system. There doesn't have to be people around it, which also is dangerous to be around these robots. And maybe you could even go for crazier construction and design big openings like this. Okay, so that's all from my side. Thanks for your attention. And now, if everything will work, I would like to play a video. Does it work? Yeah. Yay, cool. So on the left side, you can see planar prints, and on the right side, you can see non-planar prints. These are the same overhangs for both objects, 30%. Now it's 50 degrees. And yay, I think now the questions may start. It will finish soon. Interesting is that even the planar prints are having some non-planar characteristics because the material is slumping a bit and somehow is finding more convenient position of itself. Okay, and this is the 70 degrees, and you can see that the object was moving a bit, how the higher layers were deposited in there, and I had to stop it before it ended. Yeah. Okay, so that's all from me. Thank you.
As usual, yeah. All right.
We would like to continue. Okay, thank you very much for your presentation. It was really appealing, and I think that you need visuals to explain. It's really, if you have a task to use only words for your research, it's kind of a tough work, yes, to do it in the way that we can imagine in 3D what you have in mind. So I have actually two main questions. One question is about the materials. Are they to be recycled? Because we can see there are a lot of damages on the way. And can you use it more times or for something else, or it is just to throw it away? So it's the first question.
Yeah, that's a great question. Thanks. We are using a regular clay, potter's clay, which is mixed with a lot of water, and we do not put it into the kiln, so we don't fire it. And later on, that was also one of the reasons why first we use clay, so we can recycle it all over again and do a lot of testing, and then we will try the concrete, which can't be recycled.
Okay, thank you very much. The second question is about building physics or material physics. Because what we can see, I mean, that is a kind of experimental and defining or listing conclusions by observation. But if we use a bit of mathematics or about forces, or I don't know how it is in English, siła odśrodkowa, Polish students.
Inner forces. Force flow inside the object.
You know, the force that is from the center outside. So when we see this machine, right, or a robot going like this, or a printer, then it is making the whole material bump and also go outside. So is it possible to calculate how the robot should work to make this structure as you want?
That's great question. I'm an architect, so I don't know how this might be possible. I will have a consultation with civil engineers, and hopefully we come up with some solution how to kind of predict these changes. But the main issue is that when you print clay, it's liquid for a very, very long time, those 24 hours, and when you are blowing air, only a small top surface is a bit stronger, but still when you touch it, you squeeze it and it's still very liquid. So these moving things will always happen in clay. And also there is a big issue of shrinkage, because to make a clay printable, you have to put a lot of water inside. And then when you finish printing, after the drying, it shrinks by 12%, and sometimes it may shrink a bit differently. So if you would be printing some kind of bricks to put together, then you could face issues that they don't fit because one shrinked a bit more and one shrinked a bit somehow differently. So yes, that's the disadvantage of clay. But the concrete is a bit better in this, because when you put activators inside, the material sets very fast. And this slumping should not happen in a concrete, because the bottom layers would be already strong enough to to make it rigid.
Okay, thank you very much.
Thank you for your presentation. I have to know, did you build this clay printer on yourself?
Yes. I was printing it, or I am still building it, because every single time you come up with some issue or malfunction of the extruder, so you always improving it and improving it and improving it. So it's already, I think, 1.5 year of ongoing process of improving the extruder.
Okay, and for concrete, you built a new?
For concrete, you can't, or I never tested such a small scale concrete printing. For concrete printing, we use normal building equipment, so the big mixer, big pump, and industrial robot, which has a reach of 4 meters. So it's really the big scale. And yes, it's not good to do experiments in that big scale, because it's very expensive and there is a lot of waste material.
Thank you. It's very interesting.
Thank you.
Any other questions, please? Yep. It's good to move for me.
Thanks for your presentation. Have you ever tried testing how much load you can put on it? You think, is that any perspective for that? You can load some weight on that, or maybe use something for example, breach this technology?
Yes, that's a great question. Thank you. I will answer simply no. I never tried it, but I would like to, because when you are printing non-planarly, you are changing the anisotropy of the object. So maybe if you are, for example, printing a beam, and instead of printing it with horizontal layers, you can do some mathematical simulation of the force flow in the final object and adjust the layers to the force flow, so the final force will go not through the layer bonds, because these connections of the layers, they are always weak and it always cracks in there. But if you design it somehow that the most of the stress will go inside the layers, then you might print stronger objects. So I would like to test that.
Thank you, Yuri. I also have one question in regards to the scalability factor for large-scale clay printing.
Mm-hmm.
Do you have any insight into how a large-scale version of the same material with a appropriately larger diameter nozzle would react in terms of these overhangs, in terms of like the weight of the material?
In a larger scale, it would be harder to print this potter's clay, because you would have to really have a proper equipment. You can't have a pump you're using for concrete, because the clay is way stickier than the concrete. And you would have to have a big ram extruder to push it through. And I don't know how it would look like. It might be an interesting experiment, really, to just do this in large scale and see how the clay behaves.
Yeah, because like I was asking more about like the actual clay than the machinery, of course. So it's like a little thought-provoking there.
Yeah, the larger objects typically are easier to print because you have more time before another layer is being placed on top of them. So the material has longer time to set a bit. That's applicable for concrete mainly, because when you have a opening window of 15 minutes when you are using activators, you can really set it so you print 2 layers and the third layer from below is already strong or solid. With clay, you could blow some warm air in it and make it also set faster.
I would ask, how did you decide about the height of the layer at the places? If you tried like different settings, or how do you find this like this is the best for the object, and also the curves? Like you had a picture like. Yeah, how is this process going on? Like, do you at first like draw the curves in 2D or 3D, and then like test different of them, or how does this process work?
I did all this non-planar slicing in Grasshopper, and in Rhino I drew several curves and tweened them among themselves, and when it looked kind of that it might work, I used this setup. But also it's derived from the planar printing, where I observed that the object itself kind of went a bit down, deformed in these circular layers. So the non-planar layers are derived and copied from the planar object, which collapsed a bit. Yeah. So it's rather testing by doing and not by calculating, because in 3D printing it's faster to print it and see how it works rather than do a huge calculations which most likely end up with no result. Unfortunately, this is like a very alchemy, since you have a lot of unknown elements going in. It depends on the weather, on the humidity, temperature, how air blows around the object, how much water is inside, how fast is the printer, because when the printer moves, the hose moves, and sometimes when it moves in a good way, the flow through the hose is higher, and when it doesn't move that fast, the flow in the hose is slower. So yeah, there are so many unknowns that are hard to calculate.
All right, thank you, Isik.
Thank you.
Yes, so we are going to the next presentation. The author is Ampatzoglou. And his presentation is titled "A Parametric Approach for Utilizing Local Plant Capital in Vertical Gardening Initiatives." Yep, good.
Hello. Hello. Good afternoon, ladies and gentlemen. My name is Ampatzoglou. I'm a third-year PhD student at the Technical University of Crete, School of Architecture. The title of my thesis dissertation is Smart Technologies for Resilient Strategies Utilizing Nature-Based Solutions. My supervisor is a professor in urban planning and new technologies, Valina Geropada. Today, I will present to you the project, A Parametric Approach for Utilizing Local Plant Capital in Vertical Gardening Initiatives. The picture here depicts the plant Bupleurum that can only be found in Crete and is listed as endangered according to the International Union for Conservation of Nature, IUCN. Here is the city of Chania in Crete. It's the home of School of Architecture where I study. The mountain that surrounds the city, Lefkauri, is home to many endangered species and is one of Mediterranean's most important biodiversity hotspots. The picture below has an evening view from the university campus. So we live into challenging times. Climate change and urbanization put our societies under pressure. In our search, it is a moral, social, and ethical imperative that we turn to and explore practices that enhance resiliency in the built environment, such as living ecosystems like trees and plants. which bring natural life closer to humans and enhance significantly the overall space experience. However, the capacity of plants to deliver ecosystem services, such as sequestering carbon or reducing the impacts from storm waters, is species and contextually dependent. And considering the additional stresses of the future, numerous sources emphasize the urgency for encouraging vegetal diversity into the built space. Within this frame, the research project builds upon the dynamics of utilizing vertical gardening as a subcategory of nature-based solutions. Vertical gardens are attached to whole artificial ecosystems. They support diverse vegetation growth in various mediums, and its implementation entails a multidisciplinary approach like engineers, architects, urban planners, botanists, biodiversity scientists, etc. A vertical garden can prospectively be applied in various spatial scenes, from indoor and outdoor uses to private and public spaces. But why vertical gardening? The answer is that vertical gardening is a meeting point. It constitutes an array of tools that enhance resilience variously. Studies have shown that vertical gardens within the urban frame promote racial equity and social justice, filter out pollutants from the air, provide an alternative ecological habitat for insects and birds, among others. Now let's make a short historical retrospection of the technique and have a look at its composing parts. Back in 1931, the vertical garden found its origins in the monumentally horizontal farmlands of the American Middle West, where Professor White's creative intellect met the seemingly endless geography of flatness. The concept emerged in his writings and drawings in 1931, while some years later, in 1938, he patented his invention under the appellation botanical brick. The botanical brick was laid forgotten for about 50 years when Planck reinvented it in the early 80s as the vertical garden. And while the massive wet fields and flatness was the stimulus for Professor White, the keyword for approaching Patrick Blanc's work is epiphytes. Epiphytes are plants that grow on other plants merely for physical support, and they are not parasitic on the supporting plants. Blanc, as a botanist and researcher, has been exploring the rainforests since his early adulthood. The observation of the understory of the rainforest understory plants layering guided him to realize a reproduction of his observations from the natural environment into his ingenious concept, the vertical garden. Patrick Blanc initially experimented with green walls as an art form, and in 2001 he ventured into the architectural scale when he created the vegetative wall in the inner courtyard of Pershing Hall Hotel in Paris. Shortly thereafter followed a series of projects, Quai Branly Museum in Paris in 2004 and the Caixa Forum in Madrid in 2007, which established vertical gardening as a green architectural plugin. Today, highly specialized nature-based initiatives provide the design, installation and maintenance of vertical gardens, making them widely available as a continuous, either as a continuous lightweight system or as modular system. The main difference between these two approaches is that on the continuous lightweight system, the planting medium is a hydroponic felt where plants are root-socketed without soil, while on the modular system, each plant is placed separately from the others in a box which contains the growth medium, which is normally soil. The high aesthetic value of both systems constitutes the primary source of demand and contributes to their popularity. As multifunctional artificial niches, vertical gardens are used to accomplish particular technical needs and functions related to modern building architecture. However, a vertical garden permanently attached on the vertical plane has to cope with a plethora of altering conditions. Achieving these unfolding processes constitutes a dare, and thus ecological understanding and specialized design abilities are required. Thus, there is a demand to wisely employ plants not merely as objects to be admired for their aesthetic attributes. That being said, we land in the famous oasis of Abukir that covers a building's previously raw concrete facade. This 25-meter high vertical garden was installed in 2013 by Patrick Blanc and has a selection of 200 different plants and hosts more than 7,600 plants in total. A question that concerned me was about plants selection criteria that have to be taken into account for the project's realization. And somehow like this, I found in Patrick Blanc's online archive the final plant installation design along with plant botanical names. Firstly, I recorded the names of the plants in an Excel list. Consequently, I obtained from plant encyclopedias and floristic databases information regarding each plant's biotic factors. That is how I ended up with a composition of criteria. Thus, the essential criteria are plant height, the direction of plant development, irrigation request, and ease of maintenance. Equally important factors are plant's heat and hardiness zone, spread and width, which affect planting distance, the ideal pH, plant's ideal positioning regarding sun requirements and aspect. Plant's shape and bloom color, as well as flowering period, are important factors for the meta-concept, that is the intended language of structure and design. Additional criteria for consideration are plant's wind resistance and whether plant material environmentally degrades the area. To record these parameters, I used the online sources of RHS, Missouri Botanical Garden, and Gardenia. As we see in the diagram above, 99.5% of plants are familiar with a neutral irrigation pH. These vertical gardens plants' water needs are average in mostly. And lastly, Oasis of Abukir is mostly composed of plants with low maintenance needs. Digital tools constitute an important part in environmentally informed design processes. Here, I realized with Rhino 3D, Grasshopper, and Ladybug from the Ladybug tools an annual direct sun hour analysis. The simulation takes into account the existing building stock to yield the total hours of sunlight on the surface of the vertical garden. This procedure highlights how building features such as orientation can be utilized in correspondence with plants' sun requirements. Taking these into account, utilizing high species diversity provisions towards vertical gardens' persistence in pathogens, location responsiveness, and an overall environmental contribution which can be condensed as resiliency. To this direction, the relevant international literature advocates towards an insistent need for the green building sector to shift towards impact-based dialectics and application so that the driver of demand becomes biodiversity contribution. Yes, for sure. Yeah, thank you. So the main notion of this project is biodiversity contribution. But how to contribute into something and improve it if you can't measure it? The starting point is the work of Dimopoulos, Vascular Plants of Greece, an annotated checklist from 2013. This work is a collaborative effort that assembles the entire floristic region, the entire floristic asset of the Greek region. It integrates information on 5 categories: nomenclature, regional distribution among the 13 floristic or phytogeographical regions, as you can see in the map, status of the taxa as of native, alien, or range restricted, as well as chorological categorization, life form categorization, and habitat categorization. The total number of records in the checklist is 7,739 species. Currently, this checklist can only be found in a PDF format. It would be useful for future investigations that similar lists be in formats that favor cross-functionality and enable data handling. By enabling its cross-functionality and data handling, the list as a set of interrelated categorization criteria could be considered as a parametric tool per se. My current research aims at the creation of an integrative framework that synthesizes the plant's selection criteria that I presented you earlier with the checklist, and along with the complementary digital tools will estimate the vegetal potential according to the area of interest. A feasible extension of the project is the perspective of integrating into the aforementioned framework regional red list assessments of rare and endangered plants and or other georeferenced vegetal databases. Thus, this may be an initial approximation of an ecological spatial strategy that also incorporates conservation potential. In this perspective, the framework's goal is to stimulate convergence, to bring together various disciplines, inclusive and edifying strategies, and environmentally oriented actions as a form of a unified hypostasis. I conclude here with this masterwork from Paul Klee, The Dream City. It depicts his intellectual curiosity for nature and reflects an imaginary world that is full of contrast and wonder. Thank you. Thank you very much.
Time for questions.
Thank you for the presentation. I wanted to ask you if you were also considering some insect that lives in these plants as a evaluating factor, because in some flowers there might be some special type of butterfly only for one region, and if this also should be somehow measured or thought through.
Thank you for this. Sorry. I would like to create a framework that communicates with ecology. So regarding this, there are some studies that have shown that bees' abundance in cities affect the bees outside the cities. So it's like just put the data there, and this can be communicated through various disciplines.
Thank you.
Thank you.
Thank you for the presentation. I would like to maybe ask about the maintenance issue of those gardens, because like as far like what I've seen, those gardens, so most of them, they are really nice at the beginning if they make them, and then like it's really hard for the maintenance. They must maybe like to plant each year more than half of those plants again. So it's not enough just to like pour enough water there. So if you also in your research tried to like find some reasons why most of those facades in the end are after a few years looking really terrible, and if there are some that are possible to be maintained in long term and it's really working.
Thank you for this. Okay, fortunately I haven't seen a vertical garden that has collapsed or malfunctioned. Sorry. The thing is, can you repeat? Can you repeat, please? Sorry.
Yeah, I was just thinking about that those gardens are hard to keep to look healthy and the plants not to die quickly or something like this. And at least in Czech Republic, I don't know, maybe in Greece it's different, but in Czech Republic, mostly if there is this kind of facade or just element in the city where they make this kind of garden, it never lasts long time, and after pretty short period time, it's getting really ugly. Maybe it's because they are not really public money for keeping this in nice conditions. So if there is some if it's the matter of the plants that you choose, or if there are some different types that you can say this is garden and really there are some requirements so that it will work long term.
Yeah, thanks again. This framework, I'm looking towards utilization of local plant species. So it's like a kind of filtering, multiple filtering to approach the best possible species that it's easily accessible. It's abundance on them. We can find easily and work well on. As you saw, it's water needs is also considered within this framework. Thank you. I hope I covered.
If I may, I have a kind of anecdote. There is an opera building in Bialystok, not very far from here, and it is intended to be covered with vertical greenery, but it is not. It is covered only partially, and this is because the management of the opera before it was built, they changed the specification of the plans that were chosen for this purpose, and then there's a kind of a joke flying around Bialystok that the manager got offended by by plants because they do not grow the way he wanted to. Yeah. All right. Okay. Thank you very much.
Thank you. Thank you.
Yep. And now we have the third presentation, which is prepared by the students of our faculty. And the presentation is about the concept of a 3D printed tactile model of Bialystok adapted to the needs of the visually impaired. And the presenter is Urszula Leśniewska.
Yes, thank you. As was said before, my name is Urszula Leśniewska. I'm a student here at the Faculty of Architecture. I just started my master's degree, so I'm kind of a baby chicken compared to the experience of some of you. But I hope you will find this presentation interesting either way. So, we want to present to you today the development process of a 3D printed model of the city center of Bialystok. The goal of our project was providing the visually impaired people with a new way to engage with their place of living. We wanted to promote greater community awareness and better connection and belonging to the community for disabled individuals. And we also wanted to share how 3D printed projects like this can be useful and a valuable tool for city planners, architects and developers as they seek to create more inclusive and accessible urban environments. And here you can see some of our inspirations for this project, like exhibits at Tyflogical Museum in Madrid. And as you can see, these models are quite big, but we wanted to focus more on an urban structure of the city. And this was I'm sorry. This was an area we selected to show in our model. Our choice was dictated by the location of some of the most important city landmarks, such as, for example, the Opera Building or Branicki Palace and the complex around. But in the future, if this project is successful, we would also like to expand this area and show a little bit more of our city. We decided that the model should be executed on a scale of 1 to 1,000, which will enable us to provide a more detailed visualization of the city's urbanism, while still maintaining a printable size of the model. The printer that we used has a heating area that has a size of 20 by 20 centimeters, and because of that, we needed to cut the area that we were showing into smaller squares that we will then put together. And here are some of the prototypes that we were testing our models on. Yeah, they are right there. Yeah, my colleague will pass them through. You can see them yourselves, because if you have them here, why not? So the first one was our kind of a first draft. It was printed using a really large nozzle, which resulted in a failed print. You can see it's very heavy and has a really thick base. So we then cut it down and made the base more thin, but still maintaining maintaining the structure, so for it to not be too flexible. We also tested prints in different colors and decided to make the buildings and the roads different colors so that they will be easily visible. And then we were kind of questioning the color of our model, what the color should be. First, we tested some more primary colors, more vibrant colors, but in the end, we decided on a more neutral color palette. And here's some visualization of that. We liked this one, this color choice the most. We also decided on using PLA, not PLA, I'm sorry, PETG plastic, because it's recyclable, it's easy to print while still being quite solid. And then we established our workflow. So we created a base that had indentations for the roads and buildings, that had the terrain showing, but only in the parts that were quite more raised. When we were earlier testing the really detailed topography of the terrain, in flatter areas it created sort of a tactile noise. So we decided to only include the topography in the parts that were more elevated. Then on the printed base, we would attach the roads and put the whole thing together, then adding the buildings. In the future, we would also like to improve the model more by beveling the corners of the buildings, because if you can touch it right now, the corners of the buildings are quite sharp, and it can be a not so pleasant feeling to touch them while you can't see really them. We will also add a Morse code as a description of the streets. So in summary, it was a really exciting project to work on with my colleagues. We will also still work on it. Right now we are starting to 3D print the final model. And we hope that in the future it will prove to be an example how you can use 3D printing in architecture and urban design. And here I want to show you some of the people that, not some of the people, or the people that were working with me. So you can find some of them in the audience somewhere. And I want to read their names for you. So Leśniewska, it's me. Jakub Trusiewicz, Mateusz Ciołek, Bartłomiej Dąbrowski, and Mateusz Mostowiec. These are my friends that were working with me. And it was really a pleasant experience. So thank you for that, and I'm happy to hear your questions.
Any questions, please? Yep.
Thanks for the presentation. I wanted to ask, where did you get the spatial data from about the buildings and tectonics?
The data was actually easily accessible. It was easily accessible from the GIS website, but we had the most of the work actually was in the updating this data. So we had already 3D models of the buildings of Bialystok, but we had to check every single one and determine if they were still there or if we need to add new ones or change them in some way. We also had the model of the terrain, but still it was too detailed for us. It created a tactile noise, like I said. So we cut only the more elevated parts from it and then put this thing together. So the data was easily accessible, but it needed to be modified a lot.
Can I ask? What scale is the model? Because it looks like this one.
Yeah. This, like the gray area, if you can see, these are. This is actually the size. The scale of the model is 1 to 1,000.
Yes.
In the biggest diagonal, it has 2.6 meters.
Okay. So the parts you showed, where you showed the model, that was 1 to 1,000. buildings. Okay, thanks. Because we also experienced in printing urban models in 3D, and we managed to get very, very light models because we didn't need any supporting structure, because with the sloping roofs, that's easy to do. It's only a problem when you have flat roofs. So do you have more heavy? Because you mentioned the one test was pretty...
Yeah, the one that was the heaviest is the one that had the...
Because of the plate.
The base, yeah, the plate was like half a centimeter, and it became too heavy. Right now, the base is about 1 millimeter. Then we want to put it on a board that is not 3D printed, so it will save our time. And yes, we then can put all of the square pieces together on it.
How big is the size? How big can you print?
We can build up to 20 by 20 centimeters. That is our printer's print size.
But as I know, we are waiting for at least one bigger printer. Yeah. Not a very big one, but a little bit bigger. Yep.
Thank you for the presentation. It's very interesting what you did. I would like to add on the work that you already did. It would be very interesting to see also to use photogrammetry, like through aerial, through UAV drones. You can do that actually. There's a workflow that you can use on Agisoft Metashape, and you can take pictures from existing buildings that you may not have the data, because I guess you may have data, but not all the buildings. So it would be really good to see this, and also create the mesh from the point cloud. And then if you have a closed mesh, then you can actually 3D print it. So it would be very interesting to see this model created.
Yes, I think this would be a better solution for bigger building models, because the ones that we have right now are pretty simple, pretty easy to just model them yourself. But we used actually, while we were searching what to add if something wasn't if maybe some building was changed. There is this site ukośne Bialystok, and it actually shows like a the point cloud. I can't remember right now, but it shows the buildings that are kind of like the made from these like little points. So we use that when we were updating the model.
Okay, you can also use this method for a larger area as well. It doesn't have to be a certain building. You can also use it for a larger area. Yeah.
Okay, I forgot one question. Am I already? Okay. So I think at the beginning you said this model was for handicapped, visual impaired people. So you want it to be touched?
Yes.
So did you already work with those kind of people to test the model?
Not yet. During this project, we were finishing our diploma, so it wasn't really possible. But we would love to hear the feedback from the people that we want to.
Because I was wondering, you were talking about color scheme and so on, and that's not really important for visually impaired people, I guess. But the problem will more be, how big do you want the model to be? Because when you want to touch the center.
Yes, actually, this is something that I forgot to say. The the biggest size, like the range of the hand, a person in a wheelchair, is about 70 centimeters. So if you want to touch the model from both sides, you have only this 1.4 meter of the area that you want to show. So because of that, we actually want to kind of cut it in half to like create the path that you can touch from both sides.
Is there already a 3D model of Bialystok somewhere in that scale or not? Because many cities.
I don't know if I think it's not in that scale. There is a model of Bialystok, but it's the former Bialystok. It's not the Bialystok we know right now. Yeah, it's the historic model in Muzeum Podlaskie. No, we don't have a 3D model that shows the Bialystok that we know right now.
Okay, and that's also interesting for your model because you can easily replace when things change, and Bialystok is changing quite a lot. So maybe not so much in the center, but okay, thanks.
Actually, we are in touch with visual impaired people. I have some colleagues. So we plan, of course, to invite them and ask them for their preferences. But I think it's good to have some few prototypes to show them. But naturally, if something is for people with impairments, they should have input for sure.
Yes, of course. We'll love to use your connections.
Cool. Cool project.
I must say that well, we know the basic importance of consulting such things with visually impaired or other visually impaired people. About 10 years ago, we were doing the project for one of the museums that we were doing 3D printed copies of the artifacts in order to let the visually impaired people touch them and not touching the originals. So yeah, we had very, let's say, intensive sessions with these people here in the building. Yep. Any other questions? Yep.
It is really inspiring. Thank you, by the way, like encouraging us to see. I want to just like maybe a point of view. You mentioned like it is like for visually impaired, but I mean maybe it can be all accessible to everyone, like the sight impaired. Maybe like is there an option to add here, like maybe sound or even more like a smell of something relating to city memory? I am not sure, but it can be also some. Maybe there's more intention.
Well, I don't know about hearing or smell, but we thought about other people exploring the model. Like I said, like a person in a wheelchair has a range of their hand about 70 centimeters. So we took account of that. And if there are any ideas how we can make it even more accessible, we will really love to hear them. Like here's my email. You can email me with that. So yes, we will love to make it even more accessible. We thought about ways of doing that, mainly with the people that have different like a range of motion, and of course the people visually impaired. But yeah.
Thank you very much.
Thank you very much.
All right, now we are having a coffee break, and we'll meet here in half an hour. Okay? Oh, we quite early. Good.
a joint project.
All right. Yeah, we're back again. The last session of today will be shorter. Alexander Asanovich, as most of you know, is badly sick, so he's not here. We'll begin with a presentation prepared by Bart Śliwecki, together with students. Bartłomiej Dąbrowski, Jakub Trusiewicz, Urszula Leśniewska, and I think one or two more, yeah? So it will be about visual attention, real-time tracking of 3D architectural models in virtual reality.
Hello everyone once again. My name is Bartosz Śliwecki, and today I will present a tool that we have developed along with some colleagues and students from our Faculty of Architecture at the Bialystok University of Technology. Visual attention, real-time tracking of 3D architectural models in virtual reality. The project was started out with our science club called CAVE, and with a team of students, we conceptualized and realized and created a part of a larger project which we have in scope, which we called Aurela Site, which basically revolves around the ability to create data based on where people look in virtual reality on specific models. In terms of my background, I am a PhD in architectural design under Professor Alexander Asanovich, the current dean of our faculty. And my fields of research revolve around the use of virtual reality on online social platforms. So that's where the gist of my PhD work was done in, as well as computer-aided architectural design tools, which I teach at the faculty. Experimental design, which I enjoy the most in terms of practically all of the cases of architectural design, some new AI-driven concept design, and the general computer stuff. If it's computer, I'm usually there. In regards to visual attention tracking, a little bit of background information on what it actually is and how it's being used, or it was used up until this moment. The most common forms of visual attention, not only visual but also clicker attention, are web development tools which allow the user to allow the designer to realize where their clickables are. This type of research is conducted as well on mouse, on pointers, as well as eyesight through different means and methods. This same kind of concept was introduced by Dr. Thies Pfeiffer and his student Sam Mamili, in which they created a virtual reality tool onto which I based our current research and development, where the user would create a sort of heat map of where they were looking for how long, how often, and this would add up during the course of the interaction period. This would work for both static models, 3D models, and for dynamic models. Previous research from 2007, and that time consisted of using eye tracking on where people look at a screen. So much less immersive environments, more for design capabilities for flat scenarios. This same type of research was also introduced in product design, in the allocation of some of the most profitable areas in stores. There's tons and tons of these cases being used in the world. I've known a person that has done this for a big grocery store from Germany, which is quite popular in Poland, and this has been done for many years. And the problem with this was that it was, and it still is, quite inaccessible to our university or to our students. And so we tried to conceptualize and create this ourselves, along with the help of the Ministry of Education of the Republic of Poland, and they created this interesting project where students and science clubs could introduce innovations in their fields of expertise. And so, hence, Aurela site, named after our laboratory, Aurela, which had a specific goal. The goal was to help designers improve their design quality or design output, as well as optimize the production of, let's say, furniture. But for the most part, is to create an awareness of the consequences of certain design decisions from the very beginning of the conceptualizing to the actual product. The goal of the goal is a little bit different, is to change the proportions and to, at one point, much more drastically improve the design and the production so that future furniture could be made with possibly as little effort and wasted effort on things that don't matter. So if we could imagine a designer or a producer of furniture focusing on things that are invisible and using, let's say, more expensive materials, more time reviewing these areas, instead of focusing on more important areas which may or may not become apparent through testing. The technology used is quite open source and available, which was our goal. We used Blender, but of course you can use any 3D program to model the 3D models, as well as Unreal Engine as the main engine or the main driver for collecting the data and scripting the whole program. This kind of information can be used on almost any VR platform available today, which makes it a little bit more accessible. So it's not software blocked for, let's say, just one platform. In regards to the technology, our goal was simple. Make it accessible, make it affordable. There's no doubt the Oculus Quest or the Meta Quest platform is one of the cheapest available. And just through the use of Airlink or through the connection via wire, a cable, this could perform as an average to above average in quality platform for basic data gathering. The tool itself begins with the introduction of the people being tested as a sort of a walk through a type of task. Of course, the people taking part in the tests don't know what's being recorded. For them, it's more of a game. The viewers see a piece of furniture in a reasonably moderate space, which tries not to compete with the object at hand. But in reality, what they're doing is following these 6 simple steps. First of all, they're introduced to a task. The task is yet to be considered, as we are at the phase in which the main prototype is working and stable, which is one of the most important aspects of it, is that it does not crash, finally. So all those impossible check marks that we had to find in Unreal Engine have been found, or for the most part. Then they are introduced via a simple VR instruction on how to use the VR so that they are, at least in that area, capable of giving us quality data. Then they are introduced into the actual activity, which most part has them looking at the object. Interacting with the object in real life terms, so without picking up an object like Hulk. They walk around, they look, they can, if it's a small object, they can pick it up, but if it's like a cabinet, they don't. Then they are rewarded for helping us, as the research will be conducted in low-cost, high-tech, so we have a little surprise for them as a thank you note. And after the task, a survey, and the end of the data gathering session. In simplified terms, the person is the VR camera, and the object, as seen here, is a lounge chair, and the person looking at the object sees it in a realistic terms. So the data gathering session is done invisibly, as for most experiments. What the computer sees is a basic flat canvas of information, which through time gets added upon to as long as the person is looking at the object at a specific time and from a specific distance. So we're not gathering information from a kilometer away. There's a certain radius of focus area, which we also control. The data that is recorded onto the object looks like a heat map. And for the beginning part, it seemed logical for us to use this kind of data representation in terms of heat maps. So the blue area would be cold, which is not looked at. And the warmer it is, the more red it is, the longer the person looked, or the more times the person's gaze or the person's face was focused on that area. This information is mapped out onto a UV map, which the model has to have in order for the data gathering to be held. And afterwards, it is further analyzed and looked at. But there's a problem with it. As we all know, mixing colors doesn't really go well if you have too many colors. And I think most of us have played with Play-Doh and made that impossible gray-green color out of every color that we have in our reach. And so basically the same thing happened here. So we had to revert and rethink our strategy in terms of gathering this data. And we made a partial solution. We simplified it. The same data gathering mechanism was introduced, but without the colors, and which meant that we were able to use a 0-to-1 scale of black to white as the intensity, which meant that we were able to multiply and add the data to itself without creating a distorted map, which would not be realistic in terms of, let's say, 50 results stacked on top of each other. This allowed us to create a very condensed map of all that information, which basically, once it reaches the point of 1, which is basically 100%, or over 5 to 10 seconds of looking at the object, it will just stay at 1. It wouldn't continue multiplying. And through some interesting math, which at this point can't really say that I didn't, but AI and ChatGPT helps with this. And so this amazingly complex script in Python, and this is a part of, I think, the future of most architectural designers is to learn how to code. It's an amazing tool, and it helps with everything from converting colors to creating a story for a child. I created this kind of a map effect, which turned out to be a little bit more profitable in terms of data, which meant that the data was a little bit better distributed along the 0-to-1 content of black to white, and kind of like the heat vision from predator. Like I mentioned before, coding without code experience was interesting, to say the least. I highly recommend the platform of Unreal Engine to anyone who has not yet tried to work with it, as it does not, it allows us to see what we're doing and kind of understand a little bit better what the input, output, and the relationship between each section is. And so even by looking at a screenshot from Google Images, we are able to mix and match and create our piece of code that we would like to finalize through images, basically. So this is some of the logic that was behind this whole process. In terms of where we could use it in the future, honestly, and this is still a new tool. So for us, the whole industry of furniture design is our #1 priority at this point. The use of this kind of verification tool can be implemented to anything that can be represented as a 3D model, as we can map not only the areas in which people look at, but also where they were looking from, how long, and we can also gather information on a larger set of models. So, for instance, if we were to place a whole room with appropriate input, and then we can model the whole room at once and create a little bit better database. This is also an example from Sam Mamili and the professor, which I mentioned before. Although their way of gathering data was a little bit more broad-oriented, as it painted quite much more data than at least we wanted to. So this kind of previews where we're heading with this design project, with this tool. We would like to introduce more eye tracking features which would increase the data quality. There's no denying that looking with the head as kind of like an old school style Batman figure is not the way that people look. Even if they turn their head, their eyes are still a very important feature to take into consideration into the data gathering. We would like the template to be as easy as possible, introduce it, and to be able to introduce it to the field of study for open source. So this is something that we're thinking about. We would also like to have an in-house mapping evaluation tool inside of Unreal Engine, as to create a basic summary of the results without having to do this in other third-party software. Also, in the near future, if it is possible, to have a comparison of input, output, the expected input and the result output comparison. So if an architect or designer has the concept of this piece of furniture, they will create a basic painting of where they think the people are looking, how long, and like the intensity. And then we would compare that with the tool. So be able to use this and introduce this without a specialistic training. And the final one would be to be able to use it on a mobile app, which means that we can install this without the need to have super powerful computers that would basically make it a little bit more accessible than it already is. Further development will be showcased in other research conferences. At this point, I hope that the tool stays working, because this is one of the most tough parts of development is stability. And in terms of future development, I'm open for comments, suggestions, critical or constructive criticism, and debunking as well. So, thank you.
Thank you, Bart. So, questions, yeah.
Thanks, Bart, for the presentation. I've got two questions. The first one is, what was the surprise reward prize for participants?
The first version is basically a shower of 3D models falling on top of the person as kind of like a surprise element. The second would be like, yeah, this is the reaction we're going for basically. So we quantify that the prize would be worth around like €500 type. So this is like a high-end data gathering session. I'm just kidding, but like a basic game, just something for fun in VR, a quick, easy interaction style.
Okay, thanks. Now, more seriously, was the data of direction collected only from the moving headset, or also the manipulators? And does the Oculus 3 have you revised if the mimic tracking is kind of usable in terms of eye tracking features?
In terms of the Quest, facial tracking can be implemented with an additional camera. It has been done in other research projects by other universities. Hardware platforms such as the VR HTC Vive Pro Eye do allow it, but it takes a lot of skill in terms of the coding to be able to implement it. So we have been looking for semi-ready asset platforms that would allow us to start building on it, but it's a little bit more complicated than it seems. It has been done, but this usually takes the expertise of a team of coders that know what they're doing. And there's no denying that the amount of people coding in Unreal Engine, at least in Bialystok or within our reach and within our budget, is very limited. And so in terms of the hands, we have not considered recording. It is possible. It's now, like, thinking about it, it's like you just kind of like hook up instead of the face of the hand, and it should record. For us, the head was the most important aspect of data gathering, as we wanted to see if there's some kind of a pattern between the object's shape, some details, the type of material, the type of fabric, maybe sometimes even the scenery or the lighting, which would introduce a kind of relationship between the data that we gathered and the expected result that the designer would let us know about.
Thanks.
Thanks a lot for your presentation. I'm curious to hear in the experimental setup, were the people allowed to move? Could they rotate the chair? Could they move it closer, further away? Was that information also processed? So first part of the question. And the second is, okay, so then you gather the gaze information, so to speak, but what will you do with it?
Okay. In terms of moving around the object, yes, this is actually one of the biggest hurdles that we had to get over. And at one point we had the visitation of the vice chairman of the ministry over at our faculty, at which point we had problems with this kind of effect of like the head swaying away from the body. After months and months of testing and trialing and looking for partial solutions, it finally worked. So we are able to, in relationship to like this chair, we can walk around it, we can lay on the ground, we can look from underneath. If we do come closer, it does not influence, at this point, it does not influence the intensity of the gaze tracking. So if I look at the chair from a distance of around 3 to 4 meters, it is the same intensity if I was to look at a single button as I was to look at it from, let's say, 40, 50 centimeters. So, but this is something that we can take into consideration as an influence of the weight of the data gathering algorithm. And I kind of forgot the second question.
When you have this color map, the heat map, so what do you do with it?
We want to present the interested party, so let's say the designer or the manufacturer, a set of results, and to either debunk or prove to them that they're concept is working, which means that if we, for instance, the chair again, if there's some kind of an area in which the producer would like us to see if the people even look at it, they take that information and process it themselves, as most of this information is quite valuable to the producer himself. So we even wouldn't know like this type of data that we would have presented them, as this is quite valuable. And so they would basically get a heat map, which is quite more easy to understand than a black and white map. And their feedback was basically their intelligence would be based on the 3D model, which we painted with the final map or a set of 3D models, which will show areas of greatest interest. And this goes for 3D models, so like chairs and elements, to flat surfaces, so paintings, graphic designs in a 3D environment.
Yeah. Thanks for the presentation. This thing is exactly what I need for my research, so I would implement it immediately, even though I'm not a furniture manufacturer or designer. It's only pity that you do it in Unreal Engine, because I'm mostly focused on Unity, but maybe we can somehow find a way how to connect these two, or the principles at least. I was curious, you said that the scale or the heat map was ranging from 0 to 10 seconds, right, of the gaze?
Yeah.
And how long was the session per one user? How long was he or she interacting or viewing the object?
The session does not influence the intensity at this point, as if the person focuses for more than 10 seconds, we consider that area to be hot, and that's final. Like if someone reaches the point of looking at a point for at least 10 seconds, that means it has some kind of value to the user. If someone wants to look at the object for an hour, they could theoretically paint the whole map red. So this maybe this is something that maybe we could introduce as a time variant of cooling down after looking at an object. This would require a lot more programming, and so perhaps in regards to Unity and Unreal, this is exactly the reason why I didn't do this in Unreal or in Unity. As I've shown before, I kind of understand this. I have to say kind of, or we kind of understand this. Coding this way, this is still a little bit hardcore, and this is how Unity is created, as you've experienced it. Unless ChatGPT teaches us a little bit better how to code, this way we kind of are able to debug and just see the whole logic process of the action interaction and the output generated through the program. So that's why I said Unreal Engine is the most user-friendly for non-coding experienced people.
And my second question was, do you know what's the precision difference between measuring just the rotation of the head, or respectively the headset, and when you measure the retinal gaze and direction? Do you know if somebody actually compared these two, how much they differentiate?
From the top of my head, I can't say the exact measurement. This is something that we considered as a more baseline knowledge of, just looking in the direction of that speaker. I can technically look up and still be looking at the ceiling, but facing towards the object. So if I'm not mistaken, this is a magnitude of 10 to 100 times more accurate when we have the ability to focus where exactly the eye is looking. So if we imagine a matrix of a 10 by 10 framework, we can technically be looking at any one of those intersections and still be facing towards the exact center of that matrix. For us, this was a little bit the entry-level MVP that we wanted to create, and built upon this, adding more functionality, adding more higher quality data gathering processes is our next priority. But we had to do it within a reasonable amount of, I think, a year to be able to conceptualize, introduce, and test it, where the creation process took like 95% of the time. Expect like what we wrote in the grant proposal was like 20%. So we kind of had to negotiate with the ministry a little bit there. Yeah.
And only last small comment. I think that Oculus Pro, the latest version, it can already track retinal direction, so maybe you can just implement it somehow quite easily with this new product.
Yeah, like we also bought the Vive Pro Eye, which also has the same feature, but the thing is that you still have to code it. It's unfortunate that Unreal Engine doesn't have too many eye tracking presets or data packs made for non-code experienced people. I know Unity is the best for this, and I highly respect Unity for it. But we've had experience with Unity at our faculty before, and without a team of programmers, it's just almost impossible. It's just it's not within our reach, basically. So yeah.
Okay, but after Henry's question and your answer, I don't understand your goal anymore.
Okay.
Because you presented this heat map,
yeah,
with the overlay. When you can rotate the chair and look at all the different versions of this chair, then there will be different areas where you look at.
Yes.
So how do you overlay that? Because in the end, you showed this heat map with these two distinct points on the right side, which is already, I was wondering first, I wanted to ask you what was on this chair significant on this part. But when you can rotate it in all directions, you cannot more or less correlate the whole thing.
Okay, in terms of the rotation, I said it more of as a possibility than what we are implementing. The tasks that would be presented to the tested user would not have us pick up the chair, as we usually don't pick it up to look at it from the bottom. So if the person is looking, for instance, at this chair, it's more of a like a graffiti spray type of interaction, where they're constantly adding data to the texture, to the most outer shell texture of the object. Once the object is picked up, in our case, if it is a chair or a cabinet, it becomes non-realistic, and so we don't usually introduce this type of interaction. If the object is the type of pickable object, so let's say a table lamp or something that you usually pick up, then it makes sense, because then you interact with it as you would in the normal world. For us, we're focusing on non-movable objects just so that we look at them how we normally look at them. If the task was to introduce a not so natural interaction with it, as in looking from the bottom of the chair, then yes, that would make no sense.
Yeah, but even when you don't pick it up,
yeah,
you just look at the chair. So you look at it from the front, and then you move to the side and look at it from the side.
Yeah.
So, but that will be different areas that you concentrate on then in your heat map.
Yes, but
so what can you find out with the heat map then in the end?
Okay, the heat map is laid out on top of the mesh of the object, so it's not.
Okay.
It's not mapping a square in front of our face. It's mapping directly onto the object.
So it's a 3D heat map.
Yes, it's a 3D heat map. Yes.
Okay, it was only a 2D representation of this 3D heat map. Now
yes.
I understand.
Yeah, yeah. That's because it has to be laid out in a way that we can later easily play around with.
One question only, and I'm not sure. Oh, shit.
Right. Well, I did start a little bit early.
Thank you very much for your presentation. Actually, my question is kind of a following Wolfgang question. But I just wonder if who is the tester? Who is the tester? I mean, who is testing? Yes. Because I assume that at the end of the day, you have kind of a data for the company, or which chairs, which objects, what was the most appealing. So who is the tester?
This will be defined by the party of interest. So if the producer of the chair would like to have a specific age group being tested, then we would test the age group within the limits of the use of VR. So kids will be out of the question due to the fact that their use of VR is very unrealistic. The headsets are just a little bit too big. In terms of people of more experienced aged, their interaction with VR is severely limited, which is why a basic introduction to the platform would be needed before the actual test. So the sole definition of who will be tested would be decided upon with the company that would have us test their product.
All right. So,
or the design.
Because, well, from my point of view, I think that you should exclude researchers and engineers because they would focus, longer, not for the most beautiful part of the chair, but most complex or complicated, and they want to figure out how it was constructed.
Okay.
So, the outcome would be kind of misleading. Okay, this is the best chair. Maybe it was the ugliest one, but more somehow intense in watching and analyzing.
We kind of discussed this with the team, which we would have a survey asking like what the person does in their professional career, just to perhaps rule out these inputs, because if someone is interested in as an engineer, they might, like you mentioned, take too much interest into the object instead of focusing on the task. But the task itself wouldn't discredit, it would be discrete. So let's say if a person walks into the room, their task would be with a different object, or perhaps it would be to recite something, and the object will be there just as a prop. Or this is something that we still have to consider. This is the type of psychological, anthropological, sociological aspect that we're a little bit behind on, and this is something that we are still considering and prototyping.
Okay, thank you very much.
Thank you.
Well, I had a little bit similar question considering the participants of the experiment. So yeah, as you mentioned, there are many psychological aspects of where the people look. And so if you tested, who was your testing group? And if you somehow quantified the results or made some statistics about where people actually looked, and if you found or identified some patterns that you could really say, I don't know, if you tested it among students or compared, I don't know, by age, gender or whatever, that you identify the patterns that you could say, I don't know, 8 of the 10 people, you can really get the same results, or if it's really different for everyone?
At this point, I cannot answer the question as we have not done that part of the research. This is something that we are ahead of or in front of. So this is the next step, which would to see if we can find basic patterns. But at the same time, we also are thinking maybe this takes into account Professor Anetta Kępczyńska-Walczak's talk today about the constant changes of the topic. So that we're like, okay, we could start testing, but we want more quality data. Then at which point do we stop and do the testing? So perhaps we might do basic testing just to see if we can find some basic information, and then we will be able to answer that question.
Yes, thank you. And maybe there is also the thing where the people are looking, that maybe we will see that tomorrow in Adam's presentation, because there's a little bit similar topic, but well, if someone is looking at something, maybe the reason is not that it is beautiful, maybe the reason is it is ugly, or it is just really strange, something that he's not used to. So how is it possible then to find some, why they are looking actually?
But they're still looking at it.
Yeah, they're looking, but what outcomes then you can bring with that?
This is to be defined, yeah.
not exactly question, but I got some idea while you were presenting, so thank you for that, very interesting. Maybe, I know I might be boring with this accessibility and stuff, but I see a potential here to research on static information in buildings, for example, how people with disabilities navigate, how they search information to better optimize the colors, the size, the place of different, for example, toilet, how they search. Also for environment, so if there's an obstacle, how they navigate. Do they search ramp, elevators, look for people? Very interesting. So,
which is why we want to, beyond eye tracking, we'd like to make it easy to use and quite accessible, perhaps even through easily accessible Unreal Engine Marketplace for free access, basically, just so that more people could use this as a tool.
Thank you.
But thank you.
Thank you very much, Bart.
Thank you.
Thank you. And I'm inviting Arda Chalishkan with a presentation, a review on the virtual exhibitions in the fields of architecture and design. Yep.
No problem then.
So, hello everyone. I'm Arda Çalışkan. I'm an interior architect and also a teaching assistant in Bahçeşehir University in Istanbul, Turkey. Today I will present to you a review that I've done on virtual exhibitions in the fields of architecture and design. So, as we all know, we as humans wants to produce something, and we also want to, exhibit it, show other people what we have done. Even the caimans draw their drawings on the walls of their caves to represent their ideas or even cultures to the next generations. So the exhibition is important for us. We have some places, as you all know, the museums, exhibition halls, and all that stuff. But after, the development of the technology, we have a new concept, virtual exhibitions. And it's not a new concept, actually. It's been on the agenda nearly 50 years. But after the pandemic that we have faced, it's become even more widespread. So these are my research questions, what is a virtual exhibition? How is it defined in the literature? What are the concepts that make the virtual exhibition virtual? Is the virtual exhibition different from the physical exhibition, or should it be different? Can the virtual exhibition replace the physical exhibition? What are the examples of virtual exhibition in the world, and what are the common and different features in them? What are the most used programs or methods in virtual exhibitions? What are the points to be considered in future exhibitions? A lot of exhibitions. So my aim is to produce a research for the field of architecture and design disciplines, and of course an exhibition. And this study also seeks to define exhibition and virtual exhibition as well as identify which product qualify as virtual. It was anticipated that some conclusion will be reached on what feature virtual exhibition should pay attention to. So how did I do it? This is kind of a literature review. Actually, I used some databases, some academic databases, and also Google Scholar, Google. These were, the bold ones are my keywords: virtual exhibition in the design, in architecture, virtual exhibition in design fields. So like more than hundreds of exhibitions that I found, but I only included the ones which is in the field of architecture and design and in the universities. So, as for the literature, one might say the notion of exhibition has been on the human agenda from the beginning of time. Therefore, the place where the exhibition will be held has kept its significance throughout the history. Siriera states that virtual exhibitions offer several advantages over real ones. They include quick reusing of the space, the absence of the security risk for the objects on display, and the decreased cost. And the visitor, she says, more flexible in the virtual world. But we cannot say that virtual one is better than the physical one because they reinforce each other. A virtual exhibition should not only replicate and transmit real ones, but also create new exhibition and interaction areas. According to the Seraphin, emphasis should be made to sound factors while building virtual places. Yeah. So this table, I don't think you can read it, but there are like a total of 50 virtual exhibition examples that I found. These are all from the universities all around the world. You can see which country they are located in and the content of them. Like for instance, one of them is in a single website, or they did it in 3D model, or they use 2D places. So I will explain to in detail. So as for results, all of the examples that you saw before was created after 2020. That was on purpose because I think that it will be better for me to give examples, newer ones. USA had 19 examples, the most of any country, and Turkey had 18. This is because I also include my own language, Turkish language, so that's why it's the second most, I think. 38 of the examined virtual exhibitions are in the architecture and design or related faculties. The remaining 12 are in sections such as graphic design, digital arts, and art history. 33 virtual examples were created on a single website. So you just clicked one space and the project will open, and that was it. They use programs such as Miro. I don't know if you know the Miro. It's like an AutoCAD, not really AutoCAD, but it gives you a space where you can put your drawings or whatever. And they use AnyFlip. AnyFlip gives you ability to exhibit a physical catalog or even magazine. So you can use that in websites also. Some universities use YouTube videos and even Instagram, so they call that virtual exhibitions as well, which was important, which was interesting to me. And they used ArtSteps. ArtSteps is a software that I found. It basically gives you a ready template for virtual exhibitions. You just select the place. For a free version, there are like, I think 15 different areas that you can select. You just have to upload your projects and it gives you the exhibition. So I wanted to show some videos while I'm talking. Does it work? Okay. So the left side is Deakin University in USA, I think, yeah. And the right one is Istanbul Technical University. So as I said before, there are different ways to exhibit. So the first one is Deakin University. They scan their own building and they prepare their exhibition and they scan it, and that and they call it virtual exhibition. In the second example, in Istanbul Technical University, they model the space, they 3D model it, but they are using their own campus. So this is the exact campus of Istanbul Technical University, but they model it in virtual environment. Two more examples. So the left one is Talent School of Architecture. The left side used art steps. This is an art steps. They give you ready template. This is a ready template, and they just upload their projects into it. The right side that we prepared actually in our university, Bialystok University, we actually designed the whole space. This is not our campus. It doesn't look like that. It doesn't look that colorful. We design it and then we experience it. Again, two more. So the left side is Özyeğin University in Turkey as well. This is again art steps, ready template. The right side is Monash University. So this is what I mean by single website. This is also a virtual exhibition. So it doesn't necessarily have to be 3D or 3D. As long as it's in a virtual environment, it became virtual exhibition. So based on the literature review and the examples that I found, I came up with some different conclusions, which I will be talk about three different subheadings. The first one is virtual environment. So obviously virtual exhibitions are generated in a very different atmosphere than real ones. However, it should not be forgotten that both serve the same aim, which is to display the developed product in the most engaging manner possible. It should not be forgotten that the participants experience the virtual exhibition in a similar way they visit a museum or exhibition hall in real life. The design of the virtual exhibition, if it's 3D, whatever, it is important as its content. Again, visitors may prefer places specially designed for this aim instead of existing ones. The exhibition space became an exhibiting product itself. So the second subheading is content. We can use technologies like VR in virtual exhibitions. Thus, it will be more engaging or interactive for the visitors. We can use three-dimensional products such as models, apart from the 2D drawings or posters that we prepare for our juries or whatever. We can add some sound elements. And we can even use social media platforms, like how many times did we see that project, like it viewed 100 times, it get comments or whatever. As for navigation, if it's 3D, it is possible to guide those who visit the exhibition with previously determined arrow keys or images, like you see on the left side. However, the balance between this situation and leaving the visitor completely free must be well maintained. Neither completely liberating nor completely directing will solve the problem. It may be better to have the exhibition space experience as a group rather than experiencing it alone, like you see in the right picture. Programs that allow this can be used. For instance, each visitor can have their own avatar or own name, and which can be seen from the other visitors. And the time is also important, so from day to night or night to day, it can be shifted, so it can be more engaging. I guess that was it. Yes, thank you.
Who wants a mic? Of course, yeah. All right.
Yes, thank you for your presentation. I just remembered I also made an art steps once for some students' work. But my question is, do you consider spaces in online social platforms as possibly a place that would be considered as a exhibition space. So like VR chat or the non-existent now metaverse, but like the appropriate similar platforms.
What kind of
VR chat? So they're like the online social platforms. You mentioned that Art Steps has a social function, but Art Steps is kind of like for exhibitions.
Yeah,
I'm talking about like spaces that introduce exhibitions as an example of a space. Do you consider those as?
I haven't think about it actually, so I don't know.
Okay.
I don't know the VR chat. So what was it?
There's a space created for the Berlin Estra Hotel. It's like a convention hall, and they host timed exhibitions as part of their space. And I was just wondering, you know, if you've heard about it. But I highly recommend it.
Noted. Thank you.
Thanks a lot for your presentation. I think as long as VR exists, doing exhibitions in VR was one of the first applications, you know, because bitmap images of paintings, the easiest thing to implement in a VR environment. So there is already a very long history of this. So I'm curious, what do you want to add to that? What is your, let's say, innovative, different approach? Did you look at the older literature, for example? And the second aspect, of course, where these online exhibitions have become very, very relevant is because of the COVID epidemic. And then, of course, the whole meaning and application of these virtual exhibitions has become quite different from everything that was happening before. Yeah, so my question basically is, where do you go from here? What are your goals?
Yeah, thank you for your first question. So after COVID-19, in Boğaziçi University, we normally exhibit our products like you do here. But after COVID, the campus was closed, so we had to do something. We thought about it and came up with a solution in virtual environment. And we did it like 4 times now, like 4 different versions. We changed a lot. The first version was a bit like small, I think, like this kind of a space. We all did in, like the first one is actually in Pinterest. We did a virtual exhibition in Pinterest. We named each of the project by their names. And the second one was, after the second one, we tried to do it on modeling, like to model. And then the last one, we did it in VR. But the problem with VR is the amount of people who has the VR device itself. Like, we only had one in our school. So while the student comes to visit the school, the real school, we gave the headset and they use that environment. But after that, we had to do something. We are still trying. So back to your question, we are still thinking, actually, yeah. Thank you.
Thanks.
Thank you. And I also have thought about another tool that you could possibly use together with Professor Kępczyńska-Walczak. We've tested a tool called Spatial.
Yeah, I heard of it, yeah.
The thing that distinguished it from these presented tools is that you can manipulate your avatar from it behind. It's not like a first-person view, it's from behind. So as we noticed for students, because we experimented with some courses for students, it's super engaging. I mean, the thing that they can see their person, and it applies also a gamification experience, that they can see their person, their avatar, their friends, they can interact with each other, move, jump, dance, everything in this. So in terms of those kind of spaces and avatars, it's not like a bubble. It's just a real person, of course, in 3D, but it has legs and
That's a huge plus.
I heard of it. Actually, we were trying to do it, but we couldn't manage to do it. Like the problem about like the left side, the only one person can visit the place at one time. You know, you don't see the other people. You just get engaged with the project itself, but you cannot see the other people. So with spatial and of course like programs like the right one, it might be better to see other people with group. That will be better. Yeah. Thank you.
Just following Michał's comments, to add something to spatial, I'm not the dealer of spatial, it's for free, so do not blame me that I'm talking about it, but it's really a very good tool because, as I understood, you need devices, VR devices for the exhibition. In spatial, if you do not have devices, you can use even your laptop. So that's nice, because of course it's not this immersive experience as it would be with Oculus, but if you don't have it, you are still in the game, yes? You are still visiting and going through, and so this is powerful, and it has, has been developing lately very fast, and I think that Unreal guys would find also a connection with spatial. What I experienced in pandemic time, actually, I was invited to teach abroad. And of course, abroad was my bedroom and the laptop at the end. Students invented the idea that all process of design, because it was design studio, would be done in spatial. So we had meetings there. They uploaded models there. And all comments from teachers all over the world were in spatial. So it was quite nice, and some students and also some teachers scanned themselves. So they replaced the avatars, these avatars that you can pick from the catalog, for their own image. So it was also kind of inviting.
Yeah, thank you. About your first comment, on the left side, it was actually available through phone as well. So they might use their phones. But of course, spatial gives you different abilities, like seeing other people, like talking, chatting, whatever. So yeah, thank you.
Just one more question regarding, in your presentation, you showed the scanned university with the video. Is it a 360 image scan, or is this an actual fully 3D modeled space, the one on the left? This one, right? Yes.
The first one you say, laser scan, yeah.
This is all laser scan?
Yeah, yeah.
And it's like quickly available online? Like, does it not require downloading?
Exactly. It's just a website. You don't have to download it, but it's give you like a very small amount of time to download it. I mean, not downloading, but yeah.
Just stream it.
Yeah, yeah.
Wow. Okay. Is it like a universal platform? Like, is it like an easily accessible? Do you know that?
Yeah, yeah. I can show you the link. Share you the link. Yeah. This one actually on the right gives you a lot of time to download it because it's in Unity.
Yeah.
Yeah, but this is a model, this is a scan. Yeah.
Awesome, thank you.
Thank you.
Okay, any other questions, please? All right, thank you very much.
Thank you.
Thank you, Arda. Thank you. Thank you for today. For today here. We are inviting you to Lalki Bistro. I sent a link, a Google Map link on WhatsApp, and we sorry, I'm tired. We gather there since 7 p.m. But please do not be later than 7:30, okay? Yeah, so let's meet there. We'll have a nice time. I hope. Yeah. Thank you.